welcome to Tuesday night. I'm MC Toon. I was just talking with my guest, Marisa. Just a second, I'll get her up on the screen here so you can say hi to her. There's Marisa. Hello, Marisa. How you doing? Oh, hold on. Oh, hold on a second. I messed up. There we go. Now the audio they can hear you now. Hi, Marisa.
Okay. Hello, everybody. How are you doing? Thank you for having me.
Glad to have you. So Marisa sent me an email, unintroduced a couple weeks ago, and you said you had a friend that said that you should talk to me.
Yeah. Okay. So I'm actually here because I need a little bit of help, like so that I can finish. I'm doing this, like I'm building this model for myself. So like I went into this chat room and I was looking for other flat earthers. I'm looking for someone from the UK actually, that can do something for me. I'll tell you later. But anyway, so I went into this chat room and I was, debating with these other, I thought it was a flat earth chat room, but I think I was the only flat earther in there. So anyway, I befriended one of these people. His name is Flurf Hunter. And then he started sending me your links. And I'm like, I was like, okay, well, I'll email him just to say like I did. And then you emailed me back. So here we are.
Yeah, well, I think I've heard the name Flurf Hunter. Where was this chat room? Was this on Facebook?
No, it was on Telegram. It was, I think it was Flatus USA on Telegram.
Okay.
But anyway, I went in there looking for some help because I need a little bit of help from your audience if anybody's willing to help me. But
it might be possible. I don't think most of my audience thinks the Earth is flat either, but
well, that's what we're trying to prove, right?
Well, that's what you're trying to prove.
Well, okay.
Right?
So,
okay.
Do you just want to go into it?
Yeah. So we have. I'll give an overview for people. We wrote this. It's fluid. We can change on the fly, but you're going to talk about gravity, and then I might have a response. Maybe we'll see. And then you're going to talk about the major problems of the globe model, and then you're going to say something to flat earthers because you think
I'm going to tell them their problem. Yeah, I'm going to tell them their problems too.
Yep. They have a lot.
Yeah.
Then
so does the globe. So does the globe.
I was talking about something other than just the model. But then I'm going to have a response.
Okay.
All right.
Okay.
All right. Then I'm going to have a response, and we're going to have some back and forth.
Sure.
And then you're going to describe your model. Then we're going to talk about it. So,
okay.
There we go.
Sounds good.
All right.
Okay. Well, let me introduce myself. I'll give you a little bit of background. My name is Marisa Keeland. I've been a flat earther for a very long time. I put up a flat earth billboard June of 2017. And then within 2 weeks, I was in a car accident and paralyzed from the waist down. So like my rib cage down. So since then, I've been just doing the research that I can, like while I was recovering and building my own model, because this is very personal to me. Like I'm not doing this to prove it to anybody else. I don't care if anybody believes me. What you believe is your business, right? Like I can't change your mind. You have to change your mind by yourself. I've changed my mind twice. I don't know if there's some unwritten rule that men can't change their mind, but I'm a female, so I've changed my mind twice. Anyway, so what I want to do is I want to give like an overview and go back to the beginning. Like we lose sight when we get into like the macros, the micros, the particulars of each, the curvature, the motion, the land formation or the land plots and stuff like that. When we get into that, we lose sight of what our goal is. So I want to go back to like the beginning and just give an overview before I start with gravity.
All right.
Okay, so this whole debate started because calculus proved to us that infinite limits are not possible. So time doesn't stop. So at some point, there had to be a beginning. which is where we get the Big Bang theory, right? That's their solution to time beginning, right? They say you can reverse time back to this point, right? So before that, there was nothing, not a ray of light, not a speck of dust, nothing, not time.
Just for clear, I don't think that's the actual position.
Okay.
But
do you want to?
No, I don't think the actual position is that there's a claim about what was before. I think in general, the idea is that before the Big Bang is an unknown.
Right. There was nothing there. Right. There was.
We don't know what is there versus there was nothing there are very different things. So I think that I think probably the best is to say nobody claims to know what was there before.
Okay. Well, anyway, so we're not gonna go to the before on that one. So at some point, something exploded and then time started, right? So that's the globe model, right? And then on the creation side, the Quran and the Bible both say that the deity spoke into existence. The Quran says that Allah says be and things be. The Bible says that there was water and God said, let there be light. So both of the deities spoke on that. Anyway, so go back to the globe. When whatever exploded, they need gravity so that, they have an excuse or an explanation. I'm not going to say excuse, but an explanation for how everything coalesced over time, right? That's what gravity is, right? Okay, and so we're trying to take this force and put it into a box that the requirements to get in the box are it has to be naturally occurring, it has to affect all objects the same way every time, and it must be measurable. So if we're going to put that force into that box, then they've got major problems. Gravity has 3 different definitions. It's an attractive force, it's an accelerated force, and then it bends space-time, right? So, no? You're shaking your head now.
I can answer that now or wait. Mass attracts mass. That's in our reference frame what gravity does.
Okay.
That's the law of gravitational attraction. The law just describes the amount and how it behaves. It doesn't describe the why or the mechanism behind it. Then,
well, don't you need that though?
No, you actually don't. Snellis, when he figured out the index of refraction relationship for how light bends through different mediums, he did not know why. You don't need to know why to identify how things actually do work. Same thing for basically, many of the laws, the physical laws that we use, Faraday's law, Ohm's law, Ampere's law.
Okay, so then why are you trying to use the Cavendish experiment to measure that? Why are you trying to use that?
Yeah, okay, Cavendish type experiments, torsion bar experiments, test whether or not mass does attract mass.
But it doesn't.
And then how much it does. Yeah.
But it
does.
No, it doesn't. But let me just finish. Okay. So down here on Earth, it's supposed to be an attractive force because we go into the vacuum chamber to isolate gravity, right? And then
no.
Then why are we going in the vacuum chamber?
Vacuum chambers have nothing to do directly with gravity.
Yeah, it does, because that's what you're isolating gravity. Things don't fall at the same rate. Let me just finish what I'm going to say. Okay, so it's an attractive force because we calculate the accelerated force, right? It's an accelerated force, it's an attractive force, and then it bends space-time. So in space, it's both simultaneously on and off. It's on when the definition is attractive a force. It's off when it's an accelerated force and, everything floats in between. And then they're piling on this bend space-time, whatever that is. They didn't give us an experiment on how they did it or what they did or any of that. So,
There's a lot,
what did
actually.
they been? I know the definition of space and I know the definition of time, but neither one of them are physical entities capable of being bent.
Yeah,
So,
space-time isn't combining the definition of space with the definition of time. Space-time is a bit different than that.
What experiment? What experiment did they bend this space-time with? And did they bend the past, the present, or the future? You see how ridiculous that sounds?
When you say it that way, yeah, it does sound ridiculous when you say it that way. But Havel Keating did confirm that time varies based on elevation and velocity and acceleration, not velocity.
But you can't bend a non-physical object. Space is not. The definition of space is the area between two objects.
Yeah, that's not the definition of space within the framework of space-time. That's not it, though.
But what I'm saying is they don't even give you an experiment, nothing. They don't give you nothing.
Eddington 1919.
What experiment?
Eddington.
What?
From 1919.
What did they do? What physically did, what was the experiment?
Yeah.
Okay, so when we go into the vacuum chamber.
I'll answer.
Hold on just a second.
Oh, okay.
When they go into the vacuum chamber, we don't get 9.8 meters per second. And when you do it outside, no, we don't. When you do it outside the vacuum chamber, you don't get 9.8 meters per second either. It depends on what you draw because it's going through the medium. So this framework, this idea of space-time only happens if you're part of that globe model. You only need gravity if you're part of that globe model. You don't need it on the other side. And what is space-time? They don't even tell us what it is, but I digress.
All right,
okay.
Read this book. This book will help you understand what is space-time. He goes over it in here. So you asked, what is space-time? The answer is in here to give you a basic understanding of it.
The relativity, the Einstein's relativity, it's only possible if you believe the globe model. That doesn't happen.
I'm just saying, you asked, what is space-time? And I'm just saying, it's answered in here in an acceptable way.
I don't need that. I need the physical experiment that they performed.
Eddington 1919.
Okay, so what equipment did he use? Was he just using a stopwatch? How did they actually do this? Especially in 1919 when they didn't have the technology that we have today. We can get pretty accurate. We have super slow motion cameras, so that the audio bar will spike whenever you release it, and then the audio bar will spike again whenever it hits. So we can get pretty accurate.
Yeah.
But anyway, so when you come down, so in space you've got the three definitions. You've got it on for when it's an attractive mass. You have it off whenever it's an accelerated and things. Okay, but you're shaking your head again.
But that's not it. You're describing something other than gravity.
And then tell me what gravity is.
Gravity in our reference frame is mass attracting mass.
Okay, so then it can't be an accelerated force.
And attraction is that's a force, which is an acceleration of a mass.
But we don't observe objects of mass start moving towards each other unless they are magnetic.
But we do, actually. We absolutely do.
But we don't.
Yeah,
we don't.
Like I said,
you do the Cavendish experiment.
Yeah.
You do the Cavendish experiment outside of the vacuum chamber. If you're going into the vacuum chamber, because we don't observe things falling at the same rate, if you're going into the vacuum chamber to isolate gravity, then you need to do the Cavendish experiment. In the vacuum chamber. Okay,
so if a Cavendish type experiment had been done in a vacuum chamber, you would accept that?
Well, we do. We have those already, and whenever you do the math, you don't get 9.8 meters per second.
Well, you wouldn't expect that because they're not. Oh my gosh. So
if they did the 9.8 meters per second outside of the vacuum cleaner or outside of the vacuum chamber, then
hold on, Marisa. Hold on.
You got air resistance in there too.
Yeah, could maybe for the audience, could you explain how Cavendish type experiments work?
They have objects, and it's supposed to like go towards each other.
But yeah, but what's the setup of the experiment? Because maybe a lot of people in the chat don't know how it works. So maybe just like explain it.
You set it up on a bar, and you got two objects here, and then like the bar's hanging, and it's supposed to like go, right? Like it's supposed to, but you have air.
But what do they vary to test whether or not the
Well, I don't know anything that they could test, because objects don't start moving towards each other unless they're magnetic and relatively close.
Yeah, but that's your presumption that
No, it's not a
you're
presumption.
going to test.
It's an observation.
That's what you're going to test in the actual experiment, right?
If the Cavendish experiment was able to function outside of the vacuum chamber, then wrecking balls would be a huge problem.
What
They're
even is
objects
that?
of mass, right? Objects of mass is supposed to be attracting each other. Objects have mass. They don't attract each other unless they're magnetic.
Well, they actually.
So your Cavendish experiment needs to be done in the vacuum chamber, but you won't do it in the vacuum chamber because then it won't move.
So tell you what, if I showed you an experiment, that Cavendish experiment done in a vacuum chamber, would you accept it?
Well, sure. Let's see it.
All right. In fact, most of them are the new ones. The new ones are. Did you know that? Did you look it up?
No.
Okay.
No. Because I took gravity a long time ago. If you'll let me finish, I'll while you're finding that, I'll finish.
I'll get it up while you're here.
Okay, so in space or whatever, like if you believe in space it's both on and off, and then you have another definition, it bends space-time. So then you come through a magnetic field. We're going to get right back to that. But you go through a magnetic field, you come down here, things don't fall. We don't observe things fall at the same rate, so you got to go into the vacuum chamber to isolate gravity. Then we go to measurement, which is what the Cavendish experiment is, right? Because when we go into the vacuum chamber, it must act upon all objects the same way every time, right? So then so you go into the vacuum chamber, then we go to measurement, right? So then we have the Cavendish experiment. It doesn't need to be in the vacuum chamber just to be said due to gravity. So like it's on and off here as well. So if they're going to justify that force is actually a natural force of nature that's actually like affecting objects, then it's going to have to affect everything the same way every time. And then we're going to have to be able to measure it. And if you can't measure it, you can't isolate gravity to measure it, then like, why do you even, I can't justify it. Even your own scientists like Neil deGrasse Tyson, who knows what gravity is? That you only need gravity if you're on board with that motto, because everything said due to gravity can be said due to density and buoyancy in the medium around it. Like you mentioned with your glasses, it depends on the medium.
Well, there's a few problems with that, but okay. Just a second. I'm setting this up so I can share it to you so you can see.
So they're going to need to decide on which definition they want. Do they want it to be in space-time? Do they want it to be an accelerated force? Or do they want it to be an attractive force? Because you can't do all three.
Yeah, Marisa,
you can't do all three at the same time.
You keep not understanding gravity. Step one, you need to understand gravity, and you haven't understood gravity yet.
I think I know.
I think you don't.
I think it's just made up.
I understand that you might think that, but there's an empirical confirmation of it. So I'll send this.
Where?
I'll get. It's coming up in just a second here. All right.
Now my question is in the vacuum chamber, are you really isolating gravity, or are you just removing the air resistance and isolating the magnetism?
Well, that's a great question, and there is an answer for it. So here is the paper, one of many. This is measurements of the gravitational constant using two independent methods. published in Nature. Here's a little diagram of the setup there. I'll zoom in a little bit on it so you can see a little better. You can see that they have a in the middle they have a bar. You see that bar there, and then they have those spheres that they put around them. So what's
that bar made up of? Metal?
Yeah, it's a metal.
Metal is magnetic.
Yeah, but
that's another thing we're going to get into.
Yeah, they've demagnetized. Hold on, they've demagnetized the metal.
Okay.
Okay. Do you know how to demagnetize? Yeah, by leveraging the hysteresis of metal. Do you know how they do that?
No.
Okay.
Well, no, the only way I know how to demagnetize metal is you got to heat it up.
Yeah, well, there's actually another way to do that. You leverage the hysteresis of metal, and what you do is you put it near an alternating field.
So why don't they just use wood?
Yeah, let me finish before you interrupt again. All right, so they put it near an electromagnetic field that's an alternating, a time varying electromagnetic field. And then they move it away slowly. And if you know how hysteresis curves work, which I know you don't, but as you move it away slowly, it actually demagnetizes it, and it leaves it with essentially no magnetic.
Why don't they just use wood?
That's a great question. That's a great question. The reason why is because you can't get quite as much mass in a small area with wood. So they use, because you want a larger mass, it gives you better precision. So like I said, they can.
It would act upon all objects the same way every time. So it doesn't really matter if it was wood or metal.
You're right.
So
it
should act upon all objects the same way every time.
Exactly.
So you can't use this experiment anyway.
Why?
Because it's not acting on all objects the same way every time.
Why not? What's wrong with it? Specifically, what's wrong with it?
Use wood.
No. I'm not asking you to tell somebody how to do an experiment the right way. I'm asking, what is the problem with this particular experiment? Why is this one?
Because you can't remove all the magnetism.
You can't? Oh, do you have a paper on that or some?
Yeah, when you heat up metal, it loses its ability to produce a magnetic field. Hold on, I'll show you.
Okay, no, I'm not talking about heating it up. You said that you can't remove magnetism. So how? But you don't even know what hysteresis is. So I really don't think you quite have the depth in this particular field, Marisa.
I think you have a problem with your experiment.
Okay, but you didn't describe what the problem is.
You cannot remove all the magnetism from metal.
Okay.
So you can't use this experiment.
Okay, and what metal might be used in this experiment?
The two balls right there,
the
metal copper tubing.
Sure. And what do you think they're made of?
Metal, copper.
What kind of metal? What kind of metal do you think?
It says copper tubing right there.
Yeah, copper tubing. But what do you think the source masses are made of?
Do you understand that copper is like a receptor of metal? Like a magnetism?
I understand that copper is non-magnetic generally. It's
No, if you do.
You didn't know that?
Copper wires and it creates a magnetic field.
Yeah, if you pass electricity through it, it does. But if you have everything,
you don't even need to pass electricity through it. All you have to do is coil it.
Oh no, actually, you have to pass electricity through it.
No, you don't.
Well, let me check. What page of this book here? Foundations of Electromagnetic Theory. Should I find that in? You think?
How about you throw that in the trash?
I'm sorry.
Just put it in the trash.
The computer you're currently using to talk to me with is built based on the knowledge in this book.
But the problem with this experiment that you're pointing out is that it's using metal, and metal is magnetic.
Some is ferromagnetic. Some is, what are the other two?
When you heat magnetism, or when you heat magnetic things, they lose their ability to produce magnetic field.
Beside the point, that there's ferromagnetic materials, and then there's other two of types of magnetic materials. What are their names?
I don't know.
Paramagnetic is another second one. What's the third?
Look, I don't know what your pseudoscientists have said.
Diamagnetic is what it is actually.
Well, water is diamagnetic, so
that's right. That's right. And what does it mean for something to be diamagnetic?
It means it reacts to magnetism, both positive and negative.
How does a diamagnetic material respond to magnetism?
The attraction between
Wrong. It's actually wrong. Diamagnetic materials are repulsed by a magnetic field.
They are also attracted. That's how water magnets.
Diamagnetic materials are repulsed by magnetic fields.
That's how we tell the sun and the moon are magnetic. The sun is positive. We rarely see a sunset without clouds. The moon is negative. Most nights are clear. They pass quickly.
Oh dear! Wow,
water is diamagnetic.
That's quite something. Yes, it's repulsed by a magnetic field. So similarly, lead is diamagnetic, and if you're going to claim that you can't use it because it's magnetic, then just a second. Just let me finish this here. If you're going to claim that you can't use lead in this because it's magnetic, in fact, lead is diamagnetic. It is repulsed by a magnetic field. So it would actually have the opposite effect. It wouldn't attract it, but it repulses it. But when you do use... I'm not trying to use lead to just a second. When you do use lead in a torsion bar type measurement, it is still attracted, even though it is a diamagnetic material. So, all right, I'll stop sharing so you can share what you have.
Okay. Let's see if I can get to that. Okay.
So, all right, let me see here. I see Spin said, computer, turn on studio mode.
I don't know what that means.
It's a friend of mine. He has to do voice commands to his Amazon Echo to have it change the lights in his room.
Oh my God. People still use that?
Yeah. Got one right there.
Okay, hold on.
Oh.
It's in...
All right. Pat in the chat says, what rolls downstairs alone or in pairs rolls over your neighbor's dog. What's great for a snack and fits on your back, it's log. It's log. It's big, it's heavy, it's wood. It's log. It's better than bad. It's good.
Okay, so... I'm trying.
And that's log from Blammo, by the way. I'm a big fan of log.
Okay, so my point is you can't use the Cavendish experiment unless you use something that's not magnetic and you go into the vacuum chamber to do it. But you can look up like I'm trying to find it. I thought I had put it in the folder for this, but I don't see it. It's just an experiment that shows you that when you heat magnetic things, they lose their ability.
Completely beside the point, though, of course. Now, Marissa, okay, I just want to remind you, I asked you if I showed you a Cavendish type experiment in a vacuum chamber, if you'd believe it, and I started showing that to you, and you didn't believe it.
I didn't see it.
You wouldn't let me. You wouldn't let me describe it. You kept interrupting me.
Well, I'm trying to get through this. Like you said, I could describe
Tell you what,
the reasons why I can't justify gravity.
All right, go ahead. I won't interrupt. Don't ask. Don't be like right to me then, because I don't feel like I need to respond.
Okay, so we're gonna go back to like in the space. It's on when it's an attractive force. It's off when it's an accelerated force, because things float. Like I don't know like what environment we can create here on Earth to make things float. Like I don't know. Anyway, so then we come down here. We don't need to go into the vacuum chamber to say that's due to gravity. They don't give us an original experiment for the 9.8 meters per second. They don't give us an original experiment for like how they did space-time or whatever it is. So let's go back to that magnetic field, right? Okay, so on the model, the magnetic field is there's a point at the North Pole, there's a point at the bottom pole, and that magnetic field is all the way around, right? So picture yourself at one of those poles. Where are you physically located? On the South Pole, they just put a pole in the ground. There's snow there. Of course, you said snow is ice, but there's no evidence of it actually being there. You said water is diamagnetic, water is ice. If there's a strong magnetic field in that area prior to the ice being there and frozen, then there should be some evidence. If you say that it was calculated by longitude and latitude, then you have a problem because the North Pole, hold on, I'm gonna screen share this. Okay.
What about the North Pole?
Okay. Am I sharing this?
Yes, I see it. Well, I just see your file system there.
Okay, I'm trying to load it.
Your Telegram pictures there, it looks like.
Did it come up?
Just the list of Telegram pictures.
Okay, let me see if I can do it. I'm sorry, I'm new to this Zoom thing. I'm not sure exactly
That's all right.
like how to do this really. Screen share. Share this. You see that?
It's coming. There it is. Yep, I see it now.
Your North Pole is in the middle of the ocean. If water's diamagnetic, there should be some evidence that it's there. If you put salt water next to, if you put salt water next to a magnetic field, you get a moving magnetic field. If you pour salt water into a magnetic field, you get moving salt water. So where are your poles physically located? What is the evidence that they are actually there? The location of your poles is not even your biggest problem. It's the pole itself. The pole itself is your biggest problem. Hold on, let me stop sharing this. Okay, so your model calls for the hot core at 10,000 degrees, right? That's what your model calls for. At 2,000, it's supposed to be made up of iron and nickel. At 2,000 degrees, iron no longer produces a magnetic field. At 700 degrees Fahrenheit, nickel, it's made up of iron and nickel. Nickel loses its ability to produce a magnetic field. So you can't have a hot core and a magnetic field. Without that pole, there's no tilt, no wobble, no seasons, no rotation, no points to find your equator because it could be anywhere on a spherical object, no north, south, east, and west directions, none of that. And then without a magnetic field, your atmosphere dissipates into the vastness of space.
Why? Why would that happen?
Because you cannot have a hot core and a magnetic field. When you heat magnetic things, they lose their ability to produce a magnetic
all right. Well, that's a different misunderstanding.
That's your core.
But why do you think that if there's no magnetism, that air would float away?
Where's your barrier between two opposite forces?
But magnetism doesn't hold the air on the globe.
You can't, like, okay, so say you have helium in a balloon.
Uh-huh.
If you let that helium out, it's the same thing.
Yeah, but
it's going to absorb into the air.
Sure, but why if you remove the magnetism would the air float away?
Because that's your only barrier between space and here.
But that's not our claim, actually.
Then
we don't say that the magnetism keeps the air in.
Then what keeps the air in?
Gravity.
How does gravity keep the air in and is an attractive force and is
it's an attractive
force and it been space-time? Does gravity do everything? Because you're trying to fit it into a box that says the requirements in that to get in that box.
Yeah, but Marisa,
to be a natural force of nature.
Your misunderstanding of gravity isn't actually a thing, then.
Or maybe they're just
So
piling it on.
you can't debunk the globe without first understanding the globe. You can't debunk gravity without actually understanding the claim about how gravity works.
I've actually changed my mind about both of them.
The fact that you may or may not have changed your mind in the past doesn't change that you're not actually understanding how gravity works.
So gravity is holding the air in too?
Yes, that's right.
Okay. All right. I didn't know that part. So anyway, you can't have a hot core and a magnetic field.
Well, all right. So if that's another good one, I'll explain. This is a permanent magnet here. It's neodymium inside this sphere here. And
Does
yeah,
it
you're
have
right.
both a positive and negative?
It has a north and a south. Yeah.
Okay.
Or you can say positive and negative, though normally we say north and south. And
well, you can't say north and
context.
south. You can't even use north and south. You can't use north, south, east, and west until you locate those poles. That's where direction comes from.
Yeah, people have, but that's a different thing.
They haven't. What's the evidence of where the pole is?
Yeah, just a second. So people have definitely identified the north end of them. It's just it's the end of magnets being called north and south is just an arbitrary thing. It was a name given to them. So
it was given because of the compass.
So for there is a relationship. Yeah, exactly. Anyway, the cause of the magnetic field of the Earth is not that it's a permanent magnet. It's actually a dynamo. It's the movement of the liquid core of the Earth that causes the magnetic field. That's the globe's claim. The globe's claim is not that there's a permanent magnet inside of it that's hot. So if you're gonna try to say that it doesn't work, you need to, number one, understand the actual claim about what the globe says.
Well, what is liquid in your globe? In the middle.
It'd be melted metal, yeah.
Right, but when you melt metal, it can't produce a magnetic field.
Yeah, and we don't claim that it produces a magnetic field. That's not the claim.
How do you get your magnetic field?
A moving liquid. It's a dynamo. It's been produced in a lab as well.
But even if you move it, it still does not have the properties anymore to produce a magnetic field.
And that would be wrong because there has been a lab. It's been reproduced in a lab.
Hold on just a second. I'm going to show you something else.
It is magma, liquid hot magma.
No, you can't. It's not possible.
Well, it's been reproduced in a lab, so it's definitely possible.
You can do this little experiment I'm fixing to show you, and it's not possible because when you heat magnetic things, they lose their ability to produce a magnetic field.
Yeah, like I said, that's not the claim. The claim is that it's a moving liquid.
If it's melted.
Yes, liquid moving metal. Liquid moving metal.
Then it can't
melted.
Because the metal has to be solid.
So you said, but like I said, Marisa, it's been reproduced in a lab. They've used melted metal and created a dynamo, and it produced a magnetic field. I mean, just saying they didn't do it doesn't actually make that experiment go away. They did, in fact, do it.
Saying they did do it, like the bend in space-time doesn't either.
Yeah, but I can unlike generally you, I can cite my source. So I'll grab that here.
I'm gonna show you. I'm not getting anywhere near like what I wanted to do. Yeah, look on gallery and see where it's at.
All right.
Let's
get close.
Internal storage movies. Hold on, I'm looking for where it's at. Download.
All right. Let's see.
Yeah. All right. Okay. Can I screen share?
Yeah, go ahead. All right, you got it. I have mine. I have the experiment
got
ready.
it
But yeah, go
right
ahead.
now. You see it?
Yep. Yeah, I mean, you're not showing me anything that I don't already know.
I'm showing you that when you heat magnetic things, they lose their ability to produce a magnetic field.
Yeah,
And if
exactly.
you heat them up even more, you are not going to get a moving field that's going to produce a magnet your pole.
I completely agree that permanent magnets,
without
when they're
your
hot,
pole-
don't do that. So let me. All right. So I'll show you so you know.
Okay, and then without your pole, you don't have
All right.
a
Yeah, but
tilt, a wobble, rotation,
none of that actually is related. But
yeah, it is, because that is
no, I'm
where
sorry.
we get all
It's
of
actually
that
not.
stuff from.
Actually, it's not. But
It is.
no, seriously, you have to actually try to understand the model a little better. But that's fine. Here it is. Here's the actual. That's the actual chamber that they put the molten sodium in. Sodium is a metal. They melted it, and then they got it moving in a dynamo, and it generated a magnetic field.
Sodium's metal?
Sodium is a metal. Yep. Sodium is a metal.
Salt.
No, salt is sodium chloride. That would be a molecule of sodium and chlorine. So sodium alone without the chlorine is a metal.
Dead Sea. So the Dead Sea, the salt from the Dead Sea.
No, not salt. I'm not saying salt. I'm saying sodium. And you may know. Do you know that sodium is the major cation?
No.
Yeah. And chlorine is the major anion. Just for reference. So anyway, here's a dynamo action involves the flow of an electrically conducting fluid, converting mechanical energy into magnetic energy. In the Earth, the fluid is the liquid iron of the outer core, which is in constant turbulent motion because of the convection and the Earth's overall rotation. So hold on, I'll finish this.
You got to prove rotation first before you can even do that.
Yeah, okay,
rotation.
I'm happy to do that too. But such dynamos are difficult to study, particularly when one wants to understand the effects on the scale of the Earth. Experiments require massive amounts of energy to sustain large volumes of swirling molten metal, and it's almost impossible to model the Earth's inner dynamics computationally because of the huge number of variables involved. But all right, you wanted a measurement of the rotation, certainly.
No, I don't. Actually, I don't, because it's irrelevant.
You said I had to prove rotation. So right here, here we go.
I'm saying before you can say rotation, you have to prove rotation.
Got it. Yeah, right here. All right. So here is this is there it is. Here they used detection of Earth's rotation using superfluid phase coherence. So they used liquid helium-3 inside this the helium-3 or helium-4. I'm sure you care. Inside this toroid here, and they measured its motion, and they measured its motion matching the rotation of the Earth. So there's one of a short list of 15 that I have.
How did they connect up to rotation of the Earth? Because Earth doesn't move.
Well, that's you're presuming that the Earth doesn't move, but this test would test whether or not.
There's real experiments that tested that.
I'm showing it right here. Yeah, here is a real experiment that measured the rotation of the Earth.
I'm talking about the Michelson-Morley experiment that when light.
The Michelson-Morley.
The Michelson-Morley.
Oh, should we look at
No, we're getting way off topic. I was trying to do an overview, and we're getting way off topic. I want to go into.
I kind of want to get into Michelson-Morley, but okay, I'll
the
stop here.
Michelson-Morley, the Michelson-Morley is light doesn't travel at the same speed.
Don't get yourself off topic.
Okay. So anyway, without the magnetic field, you can't have a hot core and a magnetic field. Period. So without that magnetic field, you can't even no rotation, no seasons, no nothing, no north, south, east, and west directions. Gravity is the only thing holding that model together. And if gravity doesn't fit into this box, the box already has density, buoyancy, air resistance, all of that can be said due to gravity.
Droppity, flappity.
What?
Right. Flappity. That's what keeps birds up.
Whatever. Like I don't know what you guys say. I chucked it a long time ago.
Yeah.
Like I chucked it a long time ago.
Yep.
So I want to go to go back to the overview. Okay. The whole reason we're doing this is because there had to be a specific point in time or it had to be a specific point that time started, right?
Okay.
Because infinite limits are not possible. So, they're not. Calculus 101 tells us infinite limits are not possible.
Did you do calculus?
Yeah.
Huh?
Infinite limits are not possible. They made it famous in that movie Mean Girls. Limit does not exist.
Did you get your calculus knowledge from Mean Girls? I mean, it's a great movie. On Thursdays we wear pink.
No, I'm saying that infinite limits are not possible.
Okay.
So at some point, time had to have a beginning. That's what this whole thing is. Evolution. Did we evolve over time? Is it from goo to you by way of the zoo, or were we created?
Yeah,
that's what we're trying to say.
So many questions. Like, could you actually, if you could get into a TARDIS and go back before the Big Bang, could you watch the Big Bang happen?
No, because nothing existed then, and then nothing exploded.
Apparently.
Which brings up, well, that's your model. That's your model. You say that there was nothing.
Actually, then, I already corrected you early on. Okay, that's not the claim. But I just want to know if we could get into a TARDIS and watch it. Could we watch it happen?
No, you can't watch it happen.
Why not? The TARDIS can do anything.
You can't watch it happen because, it didn't.
Is it against the law?
No, it just didn't happen. It physically didn't happen. This is just someone's idea of what had happened over time to get to what we have today. Okay, so the creation model, both deities say that they spoke. Okay, there wasn't any evidence of that, but both. Well,
I agree.
Okay.
Yeah.
I say both because they're the main two. Islam and Christianity are the main two deities, and both those deities said they spoke.
There's like 1 billion Hindus.
I'm saying the one entity, Allah. Okay, Allah, the deity in the Quran says Allah says be and things be. Hold on.
But what about Vishnu?
I don't know. I'm just saying seriously, dude. Do you want to do this seriously, or you just want to make a joke? Dude,
there's 1 billion Hindus. You can't just hand wave them out of it. They have a say, don't they?
Dude, I'm doing a fucking overview. Okay.
Okay. All right.
Do you want to continue this or not?
Okay.
Both deities, but the Quran says Allah says be and things be. The Bible says that there was water, God spoke, and there was light. Okay, but there wasn't any evidence of that back then. So they came up with this model, and they're doing everything that they possibly can to get it to fit into this model. So anyway, then let me address the flat earthers real quick, and then I'll go into my model because that almost takes me into my model. Okay, so flat earthers, listen to me. Hear me, please. You do not have. You haven't located your poles either. I need to share. I need a screen share. Okay, hold on. I'm trying to get back to my thing.
Yep. I don't want to get.
You have no explanation of how it came into existence. You haven't found your poles either. Your whole model. Let me do a screen share right here. Oh,
I have their best model right here.
Hold on.
Look at that. So silly.
Hold on. I'm trying to figure out how to screen share this. Okay. So flat earthers, can you see it?
Yes, there it is.
Okay. So flat earthers, hear me please. you haven't found your poles either. You need an anode, a cathode, and the electromagnetic center. Your animation does not produce the figure 8 anomaly. The animation comes from Rob Skibas, rest in peace. His animation, all he did was put the globe model data onto the flat map, and you can't do that. You can't do that. If you're chucking the whole model, you got to chuck the whole fucking thing. Pardon my language. Anyway,
Yeah,
so you
chuck the whole
can't do
thing.
that. You gotta chuck the whole thing. So you haven't found yours. You haven't found your poles either. There is no evidence for where those poles are. If you're going to say that you have an electromagnetic center, then Polaris is not a binary star. The binary star is the dog star or Sirius, so it should be above your center. The Polaris should be above your negative magnetic pole. You don't have two barriers to produce equal and opposite double rainbows, 360-degree equal and opposite double rainbows. So you have a lot of problems too. And I would bring up these points if I was a globe believer every single time. Just like if I was a flat earth believer, I would bring up the hot core to every globe believer. Until you both either fix your models, either prove that, where these poles are, what is underneath Polaris. You can't go to Antarctica to find the wall. You can't go there to even verify that they put a stick in the ground, to say where the South Pole is. You can't go there. You can't go past the 90th whatever degree thing.
Yeah,
so
you can't go past 90 degrees south because
you can't go there.
Yeah,
but
because
you can
infinities in calculus.
Locate, you can locate. Seriously, dude?
What?
What does that mean?
Well, you were saying you can't go past it, infinities in calculus, and I was getting your back there.
Dude, are you a serious person?
Because on a globe, you cannot go past 90 degrees south.
Well, there are no southern facing shadows, so make it up matter. Anyway, you can't go to Antarctica. I'm talking to the flat earthers. You can't go to Antarctica. Why would you even want to go there to look for a pole? That there's no evidence of an actual magnetic field being in that location. You're not gonna find the permit. It's however many miles inland or whatever. I mean, depending on which model you want. What I'm saying is you can find what is underneath Polaris, and that'll prove it for both models.
You can find what's under Polaris?
Yes. If the North Pole is in the center, right? Your North Pole is in the center of your model. They're whatever they think
flat earthers, yeah.
Yeah. So put down your swords and actually locate the magnetic fields and have a reason to say why they are there. Because if you can't locate at least one pole, then you can't even begin to plot the land underneath. Curvature, motion, all of that. None of it matters until you find the location, physically locate those poles. And that is why I'm here today. I need help finding one location. I'm 95% sure of the negative pole, but I need to verify a video before I do that.
Okay.
Okay, so now that's for the flat earthers. Do you want me to go into my model?
Yes, I do.
Okay. So to start with my model, I need to screen share. I'm gonna play a short video.
Yeah, you're already screen sharing.
Okay. Well, let me get this started then. Hold on just a second.
All right. Holding.
Okay.
I've been waiting for a new model for a long time, so I'm excited for this.
Okay. So I want you to watch this model. So the first.
All right. You're not sharing right now, though.
Oh, hold on just a second. Okay. So do you see?
Yes.
Okay. So both deities, remember, both deities said they spoke.
The first time I saw sonoluminescence was in a dark. I was transfixed to look at this spherical flask of fluid. And you'd look into the center, and in the center see a glowing blue-purple light, which could be seen with the unaided eye. It looked like a star in the heavens.
Seth Putterman called it the star in a jar, a tiny spot of bright light contained in a flask of liquid. This star in a jar is made when a sound wave is passed through a small bubble inside a flask of liquid. And this sound wave makes the bubble do something remarkable. First it expands, then it collapses. And this collapse happens so violently that vapor molecules trapped inside the bubble slam together and heat up so much that the bubble gives off an incredible burst of heat and light, several thousand times a second, giving the appearance of a star.
Okay, so I'm going to stop it right there because my goal was just for you to understand the experiment.
Okay.
Okay, so stop sharing. Okay, so the experiment is a sound wave through water enters a bubble, and then the bubble expands, right? Okay, so I want to go back to this. I want to.
So this is the beginning of the world. Was this?
Yes. So you see those? Okay, am I screen sharing?
Yep.
Okay. So do you see those? The outline of this right here?
Yeah.
Okay. 360-degree equal and opposite double rainbows prove that this is actually physically happening, because when the sound goes into the new medium and it expands, the sound, okay, this is another theory of mine, I'm going to gloss over it really quickly, but sound might actually carry, like white light carries all the colors, sound might actually carry the magnetism, the positive and negative. So when it enters this new medium, it has to split into positive and negative.
So sound carries. Can you explain how does it work? How does it do that?
It's like white light. Like inside, white light is all the colors. Like it carries all the colors inside white light, but it has to slow,
inside.
Right.
Okay.
So it has to like slow and refract so that those colors separate. Right.
Oh, like through a prism. Yeah.
Right. It's the same thing with sound. When it enters the new medium, the positive and negative has to split.
The positive and negative of the sound?
Yes. We
mean
can
like
tell
positive pressure and negative pressure? There's no negative pressure, but maybe more pressure and less pressure?
No, like sound actually carries. Like, okay, so if you talk to, let's say there's an experiment, you can talk to rice. And one side, if you say bad things to it, it'll turn brown. On one side, if you say good things to it, it'll stay fresh. I mean, these are real experiments that you can do. And it happens in every language. So it's not really just the words you're saying, it's the sound that carries.
Yeah, in every language. That's kind of, does it happen in like Klingon or Vogon?
I don't know. I don't know those languages.
I need to see them, yeah.
I'm not sci-fi. Is that why you have a problem with letting go of the glow?
Oh no.
Because of the sci-fi?
No, my kid watched Hitchhiker's Guide to the Galaxy this week, and
I don't think I've seen that either. I stopped watching TV I stopped watching TV a long time ago.
Yeah.
Okay.
It wasn't on TV. Okay.
So, I stopped watching movies too.
Okay.
Okay.
So you're saying you haven't seen the new Ant-Man?
Why are we talking about that?
I don't know. I hear it's good.
Okay. Can I finish?
Yeah.
Okay. So, this same space, this space right here, we see in all. Hold on. Let me see if I can stop sharing that one. And then start sharing.
Tommy Gronvald is watching. It's what time is it in Norway, Tommy? He says, "Wow, just wow." You're winning him over, maybe. Let's see.
Okay, so these rainbows.
You're not sharing yet.
Shit, hold on.
Oh, my ears. Ow. My ears are not a sewage dump. Please.
I'm sorry. Am I doing? Okay, so what?
Oh, hold on. Can you turn off the audio? That's copyrighted, and they'll.
Oh, my bad.
It'll
I'm
strike.
sorry.
They'll flag the video.
No, I'm not sure I can. I don't know how to, like.
Well, if you like, when you play it, there's a volume control. So like, play it and then pause it right away, and then move the volume to the bottom, and then hit play again. That might do it. Yeah, over on the right is the volume control there.
Okay. I see it.
All right,
okay,
thank you.
Go ahead and play this. Can you see that?
Yes.
You see that space in all equal and opposite double rainbows. It doesn't matter if they're horizontal. It doesn't matter if they're vertical or just perpendicular to you.
I have not seen that one before. Where was that rainbow? That's pretty cool.
Well, there's lots of them. You can, hold on. Doesn't matter where.
No, I had not seen that particular rainbow, that circular rainbow before. It's really neat. It's in a helicopter.
Yeah, like you can.
All right.
And then here's another one. Play that one.
I've seen this one.
Okay, so it doesn't.
Yeah, from
all equal and opposite double rainbows have that same space in between, all of them. So the only way that is possible is that clearly something surrounds us that is reflective. Rainbows. To produce a rainbow, you have to have light has to refract and reflect back to the observer at 42,
it does that
45.
inside the water droplet.
Well, no, it doesn't. You need something reflective, otherwise you can't make a rainbow in the house without something reflective.
But you can.
At all. No, you can't.
But you can.
Yeah.
But the inside of the water droplet is reflective, and it's a total internal reflection. It's part of Snell's law.
Well, we know that water alone is not capable of doing both refraction and reflection simultaneously. Otherwise, we could make them in a house anywhere without anything, with just water alone.
But you can, yeah.
No, you can't. See, even this right here.
So if I show you a rainbow inside, what are you going to say?
Well, show me.
I want to know what you're going to say, because I'm going to test whether or not you're honest, Marisa. If I show you a rainbow inside a house, what will you say?
Are you going to show me the one with the guy in the garage with his kid?
Yeah.
Okay. He's got a metal ceiling.
And how does that make a rainbow?
Refraction.
How does that happen?
Off the metal.
Oh my gosh.
Refraction and reflection. He's got a metal ceiling. You need refraction and reflection. And if you're doing that to deceive people on purpose, if you got your metal ceiling, if you're doing that to deceive people on purpose, you should be ashamed of yourself.
It has nothing to do with that, Marisa.
especially if you're going to involve your kid. Here, let me show you this one.
Oh,
Let me
okay.
show you this one.
All right.
Why is the rainbow only where there's no
Water.
like,
Yeah, the
where-
water.
where-
Like I said, the water
Right.
droplets are necessary.
do you see the shadow right there though? There's something over it so you don't get refraction.
The shadow?
Yeah.
The
here,
shadow
let me
of
show
the
you.
water, the thick part of the water, is it's going.
No, I'm talking about the shadow right here on the ground. You don't
Yeah.
get the rainbow until it's past that shadow. Why not?
What?
You see this shadow on the ground right here. There's an overhang. Right? You don't get the shadow,
Yeah,
or you
you
don't
need-
get the rainbow
You need the
until
light.
it's past that. Right. So clearly something reflective is surrounding us. Clearly.
My goodness.
Light must refract and reflect back to the observer. And the only way that's going to happen is if there is something reflective surrounding us. And 360-degree equal and opposite double rainbows shows us the outline of that
But what about
sonoluminescence bubble
triple
that we
rainbows?
live inside. There are not triple rainbows.
Oh dear. What about quadruple rainbows?
There's not. There's only two. You can only have two because light must be refracting off two different mediums with two different properties to return the opposite result, the equal and opposite result.
Okay,
So you got one.
Could you do a diagram of the light as it goes from the sun to whatever it's reflecting off of to the eye of the observer, creating
I
that
just
rainbow?
showed you one.
No,
I just showed
could
you
you show me a diagram? You didn't show a diagram. I mean, you showed it happening, but you didn't show a diagram.
Dude, I don't think we need to because
I'm very
prisms?
curious for a diagram because that whole metal ceiling thing doesn't actually explain anything for me because somehow you're
Light
suggesting that it has
must
to bounce off the
refract.
ceiling.
no, yeah, light spreads out through the thing and it has to refract and reflect.
Yeah, but
To
a
produce
diagram
a
would be
rainbow.
super helpful. I'm just saying.
Well, show us your thing and I'll show you his.
I'm
Hold
not
on,
going to show you my thing on YouTube. What are you talking about?
Dude, please be.
Somebody got inappropriate. I'm kidding.
Please.
All right. Well, so your model so far is sonoluminescence and rainbows. Is there more? Like, is there?
Oh yeah, there's a lot more.
Okay.
So
What makes things fall down at 9.8 meters per second squared?
dude, we don't get that. We don't get that. Like when you go in and you actually try to do the math.
Does this not fall
You
at
don't
9.8 meters per second squared?
No. Do you realize how fast 9.8 meters per second squared is?
Yeah, it's this fast.
It's 32 feet a second.
That's the acceleration. So after 1 second, that's how fast it's moving. And after 2 seconds, it's even faster.
But you don't even get that for 1 second.
Yeah, of course you don't, because it's accelerating from 0 to 9 meters or 9.8 meters per second
depends.
during the first second.
But what experiment did they do? Were they using stopwatches?
Yeah, right
That's
here like
it?
this. Yeah, you can do it yourself. It's pretty easy.
Well, we do the math, and we don't get 9.8 meters.
Show me the math. Okay, I've never seen anyone actually seriously claim that things do not accelerate at 9.8 meters per second squared. That'll be a new one for me.
Hold on, I saw. Yeah.
And for reference, they
go ahead. Can I send it to you later? Because I don't have that available
certainly, sure,
right at this moment. But
yeah.
I want to get through the rest of this
all right,
model.
Well, all right, let's get to it then.
Okay, so let me screen share this right here. Okay, so you.
All right, I see it. Yeah.
Okay, so where the sound enters, like when you break a bar magnet in half, you end up with one with north and south pole, and then the other one with the north and south pole.
Yeah.
Okay.
Yeah.
So when the sound comes into this medium, it has to split. There's a degree of separation. Okay, so when that bubble expands, like the bar magnet has to create its equal and opposite, so does this. So in the center, you have that electromagnetic horseshoe, and then on each side you have a positive or a negative. Where it comes together, it splits into negative and positive. So you have a negative on one side, and then you have the positive. So
Inside that thing there's a positive and negative?
inside the bubble.
Okay.
Inside this bubble, when it expands, it automatically has to create its equal and opposite. So you have a negative, and then you have a positive that it creates. That's the anode that we're talking about. Then you have the positive, and it creates the negative. I'm saying that Polaris is under that magnetic pole. So
under?
Yes.
But we look up to see it though, not down. How is it under if we look up?
That's you understand what I mean. I'm saying that Polaris is right above this magnetic field.
Above,
and
okay.
that magnetic field is located above the Eye of Africa. Okay. So once this comes in.
But Polaris isn't above the Eye of Africa.
Well, you don't know that. You haven't found your poles. You can't tell me where your poles are.
I know where Polaris is. I can see it from here at night, and I know it's due north of me.
Well, what's underneath it?
I have no idea.
Right, that's the point. You say that your pole is underneath that.
I think there's an ocean there. I mean, there's water.
Well, if there's an ocean and water there, then we should be able to tell some effect.
Some what?
Some effects, like if you go in your boat around it, then your compass or whatever, there should be some effects.
Yeah, there are. Compasses point towards it.
But I'm suggesting that the sun, moon, and stars rotate like the tangent vectors of a bar magnet. And if you would hush and I could finish my model, then you might understand that. Just play with your Rubik's Cube.
Yeah, all right.
Just play with your Rubik's Cube and let me explain my model.
Yeah, go ahead.
Okay, so inside this bubble, you have a positive, or you have an anode, a cathode, and an electromagnetic center. So at the top, the only binary star in the sky is the star we call Sirius, or dog star. So flat earthers, hear me please. Polaris cannot be in the middle because it is not a binary star. Polaris is over the negative magnetic field. So you need to locate your poles. Anyway, so then when we go into the bubble, I'm going to go around this inner membrane, okay? So it seems to reason that if the positive magnetic field is touching positive water, then it's not going to create a spark, okay? If you go around the circle a little bit and you come to the magnetic field, skipping over the center, a negative pole and positive water would create a spark. So then I'm going to go all the way around the circle, this inner circle, and down at the bottom, we call those waters brine pools. And the reason that I say these waters are charged is because electric eels go into the brine and then come out charged. That is a video you can look up yourself. Anyway, so then I'm going to go all the way back around. And go back to the center. The reason that I say that the binary star, the Sirius binary star in the center is not inside of the bubble is because they don't show up in time lapses. So they must be outside of the bubble and rotating around the outside of the bubble. Are you there?
Yeah, I think my network dropped out for a second. So I'm back. I can see you again and hear you again. So I missed maybe the last. Yeah, I missed maybe the last minute. All right. Somehow my network dropped out. Can you hear me?
So where did I stop?
It was you were talking about that professor was on screen there, and you were talking about the bubble. Okay.
So the bubble or the the stars that are outside of this bubble don't show up in time lapses, so they rotate around the center like this. Do you see that?
Yeah.
Okay, so then we go inside of the bubble and we see the stars rotate clockwise and counterclockwise. Okay, so I'm gonna play this video real quick.
Okay.
And this is where I'm gonna tell you I need some help. Okay, so let me load it. Okay, so okay, we're gonna watch this real quick, and I'm gonna walk you through it. Okay, this guy says he did the star trails, and at the end he's got. Can you hear me?
Yep.
Okay, and at the end he's got what he did. Okay, so I'm gonna walk the we're gonna watch this, but I want to walk you through it. Like, can I do the audio on this?
If it's not copyrighted music, yeah.
Is it?
Yeah, it sounds like just kind of staticky stuff, yeah.
Yeah, it's just okay. Can I play this on 1.5? It's kind of.
Oh yeah.
I'm trying to figure out how to do that. Okay, so at this first part right here, you can tell there's a pole star, right? He has other videos on his thing, so I've assumed that he is in Africa. He's got other videos on his webpage or on his YouTube page that I assume this is Africa. So then there's this second one, right? And it's kind of
for that. It looks like it might be a little bit too high in the sky for any part of Africa to be seeing the center of northern rotation.
This guy did. I mean, I'm just taking it from this guy.
Okay.
You're taking your stuff from your books. I'm taking the video from this. Okay, so you see where the pole is right here?
Yes.
And he just moved over some. Okay.
Yeah, he panned the camera. Yeah.
No, he moved a location.
Okay.
So he was at one location. He moved location.
So which way? So he's still pointing north, though, right?
I don't know which way he's pointing. I'm using the.
I recognize that. That's pointing north.
Okay, so let's just do this. If I can get this to move any faster. Okay, so then he's got this one right here. Where the stars move in straight lines.
Yep.
And the moon is there on the equator. So the only place you should see the stars move like this is at the equator, correct?
The celestial equator is where you see the lines going straight. Okay. But that's not where you need to be. You don't need to be located at the celestial equator.
Well,
but that's where you will see the lines going straight.
Okay. And then we've got the other one going the opposite direction. So we see stars move. They go equal out counterclockwise and clockwise.
Yes.
And then they move in straight lines in the middle.
Yes. Yeah.
No pole on this one. You see this here? No pole on this one.
Well, there's a pole. It's the center of rotation. Is the what's called the South Celestial Pole, is the center of rotation. There's no star exactly at either north or south celestial pole.
Right. So in my model, when a positive magnetic field hits positive water, there's not going to be a pole. It doesn't create a spark. Positive doesn't create a spark.
Okay.
Okay, so now we see this. His next thing is his credits. Okay. So he's got his credits here. He says his first location is
Guernsey.
the UK.
Yeah. All right.
Okay. I need somebody from that location to verify if it was the first part of the video we saw.
Yeah.
That
with
second
that,
little part.
that whatever
where
that
he-
church or something that was in the foreground.
Right. Whether it's that first location that he saw, whether it's that little bit in between, whether it's the one where it moves in straight lines, or, well, I don't think it's the other one, but I need to know which one of those three is he calling location one to verify it. Because I say that the sun, moon, and stars rotate like the tangent vectors of a bar magnet, not a pole and axis. So,
Okay. Now, for reference, Guernsey is about 49 to 50 degrees north latitude. So I live in Minnesota. I live in Minnesota at 45 degrees north latitude. So, 240 miles north.
Go out and check your stars. Like, do they move in straight lines?
Well, if I look north, there's a north center of rotation, and if I look south, there's a south. I can't see the south center of rotation. I can just see the curve, and then in the middle, there's a straight. They go in straight lines.
Okay.
I have
I'm not sure.
where it is. Oh, it's over there. I have a P1000 over there that I got some star trails with. Yeah.
I got one too.
Yeah. So
Anyway.
so you from your location you can get straight star trails. Yeah.
Mine move in straight lines, and the only way that would be possible on a globe is if they were near the equator, right? Well,
No.
the U.S., the U.K. are not
No,
anywhere near the equator.
You can always see them as long as you're not right at the poles, generally. Yeah. North or South Pole. So 5 degrees south of the North Pole, you'd see the horizontal moving stars rather low on the horizon. But yeah, you'd want to move farther north, or farther south. So at 45 degrees north latitude, that's a fine spot. And I think if I'm right,
So
you're south of Minnesota. Is that right?
I'm in Oklahoma, like
Okay.
close to Oklahoma.
Yeah. And
Anyway,
then- Yeah,
I need somebody to verify how the stars move, so I can say whether that middle one is where his first location was, or the first location like for his thing. So I need somebody to verify, because I couldn't get him to email me back.
So you want
like
somebody in Guernsey.
Well, anywhere in the UK. Mine move in straight lines. In the center of the flat Earth, they would move in straight lines and then rotate clockwise and counterclockwise. Like a bar magnet, not a pole and axis, but horizontal, like a bar magnet.
But why just Guernsey? Guernsey is rather...
I don't care about what city. I want somebody from the UK to verify how their stars move. That's it, period. Because if that's how their stars move, then Polaris is above the Eye of Africa. Okay, so let's go back into...
I'm missing how Polaris is above the Eye of Africa.
Because it cannot be a center star. It's not binary.
But it is a binary star, and I don't know why.
No,
It
Polaris
has-
is not a binary star. The only binary star in the sky is Sirius, or the dog star.
Well, why would
So
you
on
say
the
that?
flat-
That's not even close to true.
It is true. It is true.
Marisa, it's not.
Yes, it is. The only binary star in the sky is Sirius, the dog star. Polaris is not a binary star.
But Marisa, it is. Why are you saying that?
Because
Why
it's
would you
not.
say that's silly?
Because
Marisa,
in the
it's-
center, it's made up of both positive and negative. So when you hold your magnet flat to go around that center point, it's always going to point to the center, because it's made up of both positive and negative, and it's reacting to its environment. So when the bubble expanded, it created the anode and cathode, and then you have the electromagnetic center. So the only binary star in the sky is above that electromagnetic center. So Polaris must be above the Eye of Africa. That's where I'm putting it. I'm saying that the negative field is above the Eye of Africa. And the positive field, I'm not quite as positive about that one, but I place it at East Wabaton Crater in Australia. And the reasons that I place these here is because the pole star, I'm going to start with the negative one, the pole star, okay? The way the stars rotate clockwise and counterclockwise, I think it's counterclockwise. From my perspective, on that side, it would be clockwise. So counterclockwise. Then at the cloud level, clouds avoid the area. Like there's a pilot, his name is Pilot LX on Facebook. Am I still screen sharing this?
Yeah, you are. The credits.
Oh, sorry, my bad. Let me stop that.
Just for reference, I spoke incorrectly when I said that Polaris was a binary star. It's actually a trinary star, and Sirius is there's 5.
What?
Yeah,
The dog star is just a binary star.
there's 5.
No,
But what is
Okay,
well then
anyway,
explain
anyway.
What is a binary star?
it's made up of both positive and negative.
Actually, no,
When-
binary star. There's 2 stars.
No, it's made up of both positive and negative. Because
And-
the
and how do
stars
you-
are.
How do you
stars are-
measure? How do you measure that it's both positive and negative?
Well, it's.
Like I mean astronomers, they have methods that they use to identify whether or not a star is binary, trinary, quadrinary, pentanary, sexenary, septenary, octenary, nonary, and decanary. I don't know. I could be wrong.
I
I'm
don't
just making them up.
understand where you're getting all these. Yeah, you're really not.
I took Latin in high school. Not
Really?
that I remember any of it. We played hearts basically. I got good at playing hearts.
Dude, what are you talking about?
The game Hearts. So there were
I'm
5
not
of us.
interested.
There were 5 of us in my second year Latin class.
Why are we talking about your Latin class?
4 of us would play hearts, and the fifth, he would translate Caesar. And then for the last 5 minutes, the rest of us would copy off of the translation that he did. You asked how I knew how to say binary, trinary, quadrinary. That's how.
No, I'm really kind of tired of you making shit up.
Okay. No, I didn't make that up. I really did play hearts my senior year of high school in Latin class. And I really did learn a little bit from it.
Sirius is a binary star.
All right. It's booting up your share here. I don't see it yet, but there it is. Okay.
Never gonna get through this model.
It's coming a little slow. I know. We do keep getting off track.
I'm just saying that Sirius is a binary star, and that's what I'm showing you. I'm pulling up. Sirius is the binary star. Okay. Sirius is a
There
binary
you go.
star.
All right.
Okay. So the only freaking star in the sky that's a binary star is Sirius. So if the flat earthers, you have a center magnetic field made up of both positive and negative, then your binary star is Sirius and it's above the center. That makes Polaris above the negative magnetic field. So then when we go into, okay, so let's go back here. We went around the outside bubble, so let's go into the middle. You cannot make a rainbow in the house with water alone. So inside this bubble, back to it, sorry. So inside this bubble, the 360 degrees equal and opposite double rainbows show us the outline of that bubble.
Are you trying to share? I don't see any.
Yeah, okay.
Oh,
So
here it comes.
inside you have the positive, and then for it to return the equal and opposite, it must be reflecting off of another medium with different properties. Otherwise, we would just get the same sequence if it was, just water alone. because water can't distinguish between like how it wants to reflect back to you. You can't do that. So this space in between every single equal and opposite double rainbows shows us the outline of that sonoluminescence bubble that we live in. And if you believe the Bible, you said something about Jesus. I haven't decided yet if it's true or not. But the first three definition, or the first three sentences in Genesis describes this experiment, describes that God spoke through water to create you.
Okay. I'm still missing how sonoluminescence has positive and negative, and how that relates to stars, and then really how does that relate to the eye of Africa? I'm very confused about that relationship.
Because I'm trying to locate the poles. I need verification of that location so that I can locate the poles. You don't know where your poles are located. You can. There's no evidence. You don't. There's no evidence there. What evidence do you have that the pole is there, as opposed to 5 miles that way or 5 miles this way or in any direction? How do you know it's specifically there? I'm trying to locate these poles.
Do you mean the magnetic pole
not,
or the geographic pole?
Whichever.
They've both been measured very precisely.
The sun, moon, and stars are rotating around something. Where is it located, and how can you tell it's there? If water is diamagnetic and it's in snow, water is ice, I think you said the other day.
Yeah, water is ice.
So there should be some effects.
What kind of effects do you expect? And what magnitude?
Swirling water. Something.
So like if I take
magnetic field in the area.
Yes.
No.
So if I take this magnetic field and put it next to water, the water will swirl.
Mm-hmm. When you put salt water next to a magnetic field, you get a moving magnetic field.
So if I go and I put a bunch of salt in water and then put this, because this magnet is significantly stronger than the magnetic field of the Earth. So if I put this near water, then the water will swirl.
Mm-hmm.
All right, I'm not going to do it right now. But what if it doesn't swirl? What are you going to do then?
Do you want to see?
What happens when you put
an experiment?
A magnet next to salt water? Oh, yes, I want to see this.
Okay. Let me play it real quick on. Get this one. Let me play it real quick on YouTube so that I can just pull it up on my on YouTube. So screen share.
Icy Spin is wondering, how does the metal ceiling above cause the rainbow?
As it's reflecting the light. Hello.
Yeah. I mean, I think he's back to, like I was asking for, where, a diagram would be cool.
Because it's reflecting the light. Okay.
All right. Are you...
It's there.
How's it going?
Yeah, there it is.
So does it mean something different if the double rainbow is all the way?
What?
Like some people think that if the double rainbow goes all the way, that it's different. It means something.
Well, the only thing it can do is refract and reflect. That's it.
Yeah, but
it can't.
But it doesn't necessarily. Maybe
that's how rainbows are produced. They refract and reflect. That's the only way it can.
Yep. I mean, inside the water droplet.
It's not. Then make a rainbow in the house with just water. Go do it in your kitchen. All you need is a bowl of water, a flashlight, and a mirror to make one.
A mirror? Why a mirror?
You need something reflective.
But how does it work? Because I can give you a diagram of how it works inside of a water droplet.
Right, but you can't make a rainbow in the house with just water. You need something reflective.
Yeah, but I'm asking, like, how does the reflection that's not near the rainbow make you see the rainbow? Just because it's in the room, does it like convince the light to look different, or does it actually have to bounce off of the reflective surface somehow?
Yeah, that's how rainbows are produced. That's why we call it refraction and reflection.
What
It has
does
to refract.
all right?
It
What
has
does
to refract.
what does
Did you let me
refraction
spin-
mean? What does refraction mean?
It has to slow. That's why a prism is made the way that it is. It has to slow during refraction and then reflect back to you to split the light. That's how a rainbow is produced.
Yeah, but what does refraction actually mean?
It slows the light and it changes direction.
Okay, there you go. And what's the relationship called?
They have to do both. It has to produce.
Yeah, but
has to
there's a
correct.
law. There's a law about it. What's that law called?
I don't care what the law is called. Here, let me show you this.
All right.
Hey, can you see?
Yes. So which one is the magnet?
In this experiment, we need a magnet. So this is a
Okay.
magnet, not a coin.
Okay.
We also need a container, where the inside wall is covered with aluminum foil.
And what are these wires to?
The power.
The foil in the center pin will be connected to a battery. Make sure the magnet is right under the center pin. Fill the container with a strong solution of ordinary salt and water.
Watch the middle. Watch the bubbles.
Now, connect the battery. The bubbles are hydrogen and oxygen, and is a byproduct of this experiment.
That's your shooting stars.
The real effect the experiment demonstrates is that the water rotates. As you see, the water rotates clockwise. See the description of the movie for an explanation of why this happens.
Okay, so let's stop sharing that.
That's just hydrolysis.
Right, but you should have some evidence. Are you there?
Yeah.
Why am I looking at me? Okay, there. Okay. So you should have some evidence. If your magnetic field is in the middle of the ocean, you should have some evidence. There should be some evidence. How can you tell where your poles are located? That's what I'm trying to do.
But
I'm trying to locate my pole.
demonstrated, but that was hydrolysis.
No, I'm telling you that if your pole, your magnetic field is in the middle of salt water, then you should have some evidence.
But Marisa, you showed hydrolysis. You didn't show a magnetic field doing something. You showed hydrolysis. Electricity passing through water, disassociating the bond between the hydrogen and the oxygen.
So you're saying that the experiment is not correct? Is that what you're saying?
I'm saying the experiment is fine, but you didn't show what happens to a magnetic field. You showed what happens when you pass electrical current through water.
It's underneath. The magnetic is underneath.
I understand that the magnet was put under there to trick the observer into thinking that was related.
Well, then recreate the experiment without the magnetism.
That would be on you, not me.
I'm saying that you should have some evidence where your poles are located.
And we do.
If you
Yes, we
believe-
definitely do.
Then what is the evidence that it's in the middle of the ocean? Because I thought it was on land and snow.
I don't know why you thought that. It was quite a while ago. In the 70s, it was over like Resolute, Canada, very far north. But
so if your pole keeps moving,
yeah, it does.
Where is it located? It's
in the Arctic Ocean now. Yeah.
If your poles move, then wouldn't your sun move too, since that's what's rotating around? And
no,
your moon would move
the
too?
magnetic poles of the Earth has nothing to do directly with the rotation of the Earth. What? So the rotation of the Earth generates the magnetic. Is part of the generation of the dynamo.
I thought it came from that.
Yeah, just a second. I'm explaining it. I've let you talk, Marissa. I've let you talk an awful lot.
Okay.
So you don't need to interrupt me when I'm explaining it.
Okay.
The Earth rotates. The rotation of the Earth is part of the dynamo effect of the liquid metals inside the Earth moving to create the dynamo, to create the magnetic field of the Earth. That's fluid, and so it can move. And so that's why it does move. The magnetic field doesn't determine the rotation of the Earth around the sun. It's the other way around, or the rotation of the Earth. It's not actually related directly to the orbit of the Earth around the sun. In fact, if there was no magnetic field of the Earth, we would continue to orbit the sun and we would continue to rotate. Mars doesn't have a liquid core to their people's best understanding. Same thing with the moon.
How would they ever know that?
Because they've been studying it. So,
they've been studying your imagination.
No, not
it's
my
not real.
imagination. So you say.
It's not real.
So you've said, but I mean, there's a whole lot of denial, but not.
Well, where are your poles? Because that's if everybody puts down their swords.
You keep going back to your misunderstanding of it.
You got to go back to the foundation. If your foundation is flawed, then the rest of it's going to be flawed.
But that's not Marisa. That's not the foundation of it. Earth's rotation is not because of the magnetic field.
You can't prove any rotation.
I showed you. I already showed you measurements of it. You just said no.
You like physically outside, like we're trying to make a model of what's physically outside, right? So outside we see the stars and the sun and all that rotate around us. There's no rotation of the ground. The ground doesn't move.
But it's been measured. Marissa, it's been measured.
If the ground moved, then freely hanging things, like your Cavendish experiment, right? Freely hanging things, wrecking balls would be a bigger problem.
But why? Why would something moving at a consistent velocity be affected?
Then how can you measure it with the Cavendish experiment?
Then Cavendish doesn't measure rotation; it measures something else.
I'm sorry,
what? You went from rotation to Cavendish. They're not the same thing.
You're supposed to be like measuring gravity, right?
Yeah, gravity is not rotation. They're separate things.
But that's what's causing the rotation, right?
No.
Then what's causing the rotation?
It's just conservation of momentum. It is rotating. It is continued rotating.
So your imagination. You can't prove it.
No, I showed you measurements of it. You didn't like it, but I showed you measurements of it.
No, I'm talking about physical motion.
Yes. The
Physical
Earth
motion.
physically moves and it's been measured.
No, it hasn't. We have the Michelson-Morley experiment that returned a null thing.
Okay.
Like they sent out a light. They sent out a beam of light, and if it's moving, then light doesn't travel at the same speed.
Okay,
do you want to see that one too?
Maybe if you explained the Michelson-Morley experiment a little better for the audience.
Okay, so they said, the Michelson-Morley experiment, they said that we would be able to measure the rotation opposite what the medium that it's in, right? So in space, it's in just, it's in nothing. In the flat Earth model, then it's in water. So if the Earth is rotating, then we would be able to send out a light beam and it would return at the same, it wouldn't return at the same rate if it's moving. But if we send out a light beam and it returns at the same rate, then it's not moving.
So
When they
how
send
did
out
they?
the light beam,
But in this, how did they measure the rate?
I don't know. Like it's an experiment that I mean, you can look it up. It's the Michelson-Morley experiment. And they sent out this light beam, and there are other experiments like the SAGNet experiment that proves that light does not travel at the same rate on a moving object. Would you like to see that?
Yeah, explain that. I still don't quite understand maybe what you're talking about with the Michelson-Morley experiment.
You don't know the Michelson-Morley experiment?
Well, I mean, I do, but the audience probably, you understand, right? I've read these things and stuff, and seems you might have, but the audience doesn't necessarily, right? So there will be, a few thousand people that'll watch this in the next week or two. So not all of them will know about this. So so here we go. We have a few people are like, they don't understand. We got Guil Carlos says, I don't know about it. Please explain.
Oh, what?
We've got Tau Software says Mitchell's son Morley. Is confused about that, I think, yeah. Sir Little Wolf doesn't know about it. So yeah, we've got a few people asking about it. So yeah, if you could just like explain it in detail, how they measured, what was their purpose in what was the hypothesis maybe? Yeah, Glitch says, yeah, I'm clueless on the experiment. Please explain it in detail. Adam Johnson says, explain, please. Me, Team Kiwi, somebody from New Zealand, is wondering about it. So Charlie Welch says, I've never heard of it before. Please explain. So we've got a good amount of the audience here who's wondering about it. So
Okay, so I'm going to show you this experiment.
yeah, Dave Fierce says the Michelson-Morley measured the Van Halen belts.
No, they didn't.
Glober Mom says, I'm a little fuzzy on the detail. Can she please explain it?
Okay, so the Michelson-Morley, they sent a light beam. They sent a light beam, and if the results come back that, hold on, let me just show you this
Where
video.
did they send the light beam? Like, where was this, like, how was it set up?
Why don't you Google the Michelson-Morley experiment?
No,
I'll get this.
I have it, like, I know about it, but I think it's fair that you describe it.
So let me get to YouTube.
YouTube.
And I'm going to show you this.
You could just
Well,
pull up the paper that they wrote, I suppose. That's what I did.
No, I'm showing you video.
Oh, okay. Sean O says, please tell her she sounds very, very expert.
Thank you.
Quark says V squared over C squared for the win.
Okay, so let's I gotta wait till this. Sorry, it's got ads.
Yeah, it's all good. Glober Mom wonders if you know who JM Truth is. It's probably for the best. JM is trouble.
I don't know who he is. Like,
Yeah.
I don't do this for anybody else. I'm just doing this for myself.
All right.
Okay,
is
can you
coming
see
up?
it?
No, it's you're not sharing yet.
Okay, let me.
All right.
Okay, so if you will watch the see if I can start it over. Am I sharing?
Yep. I see it.
Okay. Okay, so you see how it changes the fringe over here in the back? See how it changes on the moving?
Yeah.
That's how we prove that light does not travel in the same speed on a moving object. This is a SAGNet experiment.
Yeah, that's not the Michelson-Morley.
Right, but you need this first because this is what they were trying to prove with the Michelson-Morley experiment. They were saying that light does not travel at the same rate on a moving object. So it's on a moving object.
That's what they were
and it's
saying?
not traveling. Yes. So when they hold on, let me go back and stop sharing this. Okay, so when they did the Michelson-Morley experiment, they were saying that they would be able to detect in the fringes that light is not traveling at the same speed on a moving object. So therefore, we wouldn't have a consistent speed of light. Not that they've ever pinpointed a photon of light to even know what light is made up of. But whatever, I digress on that.
Okay.
They haven't. What experiment?
So
Also, whenever you need, whenever you're pinpointing something, like to know like how fast it's moving, whatever.
yeah.
Like if I want to know your age, I need to know your birthday, right? So they need to know like
Yeah.
the initial velocity.
February 18.
Well, mine's the 11th, but anyway, so
All right.
okay, so then you need, what was I trying to say? You need to know the initial velocity of the light, and you need to know when it comes into existence. They've never pinpointed a photon of light to even know how much light, like how fast light was going. Its initial velocity.
Well, its initial velocity is c,
What's that?
the speed of light. You
Right,
just,
but they
just use c.
What experiment? What experiment?
Actually,
What experiment?
funny enough,
Here.
Albert Michelson got the Nobel Prize for measuring the speed of light.
Oh, really? I thought that was an Einstein thing. What's it look like? What's a photon look like?
What does
We got a picture of an atom.
What does the particle
We got a picture
that
of-
tells us how things look like?
Yeah. What's it look like? We get an artist rendition of everything. We got an artist rendition of COVID, okay? But nobody can come up with what, they pinpointed it. They looked at it. They found out how much its initial velocity is and all that, but
Marisa.
they can't tell us what it looks like.
Marissa, you can't look at a photon. A photon is what we use to look at things. That's the
then
messenger particle that we
How do you
use
know
to
how
look
fast
at
it's
things.
moving? Then how
Albert
do you know how
Michelson
fast?
measured it.
Wow.
It's actually, this is amazing. This is super cool. They actually use the speed of light to determine the length of a meter.
So they use something made up to determine the length of a meter.
No, in fact, no, not at all.
So how can they say that when they don't even know the initial velocity? What's the initial velocity of light? Or does light always travel in
It always
like at the
travels
same
at the
speed?
light always travels at the
But
speed of light.
But
Yes.
it doesn't. But it doesn't because we have this experiment right here that
Which-
shows it's not.
But this
That shows it's not.
in fact, right here in relativity, special relativity,
Einstein was a moron. All of Einstein's.
Hold on. I
All
want
of
to be clear.
Einstein's.
Do you think you're smarter than Einstein?
Yeah. Because all of Einstein's theories depend on not having an aether, depend on not having a medium inside this bubble. All of them. You want to know why I don't believe Einstein? Because all of his theories start with imagine if.
Marissa, you're not smarter than Einstein. I just tell you that.
Well,
Oh my gosh. I don't want
there's an aether.
no.
We have an aether.
No, there
And all
isn't.
of his theories, relative, all of his theories depend on it not having an aether. We see the SAGNet experiment shows that light does not travel in the same lines. We show 360-degree equal and opposite rainbows. So we are in an inflow system. It doesn't matter if it's vertical,
I'm
horizontal.
still missing this whole rainbow thing. It's it's baffling why you think there's only two, and it's baffling why you think that there somehow there's a polarity that's happening. It's quite something.
I'm not sure what you're asking me.
I'm. Oh, I've got a puppy here.
A doggo.
My goodness. Hold on. This is Penguin. Hold on a second.
On the globe model, so how does on the globe model, how does rainbows, 360-degree equal and opposite double rainbows, how are they on a globe?
Well, yeah, rainbows happen by what happens is they
Just water?
just
I know what they say.
then why do you ask?
It goes into what? Because I'm asking you, how can you say there's nothing reflective?
So
if you can't make one in the house.
The inside of the water droplet, the angle of the light hits the correct angle, so that it gets total internal reflection. It's part of Snell's law. So it goes as the light enters. Hold on, I wasn't done.
But water is not capable of doing both simultaneously because they depend on angle.
I wasn't done.
Okay. Well, I know how the mainstream media tells us that rainbows are produced.
I think you don't.
But
The way you've described it tells me you don't, actually.
Well, then make a rainbow in the house.
Already
with
done.
With water alone.
But your denialism was too powerful for it.
Well, okay. So make a rainbow in the house without a metal ceiling.
No, it's too silly. It's too silly, Marisa.
You can't. It is physically impossible for you to do that. You can laugh all you want. I'm challenging it.
I'm asking you to describe how it works, and you won't describe how it works.
Light must refract and reflect back to the observer at a 42 to 45 degree angle.
That's just a buzzword catchphrase. How does it actually work?
Light refracts and reflects. It changes, it slows during refraction and changes direction, and then when it reflects back to you, it splits the light. When it comes back to the medium.
But why is there a reflection that's external to the water droplet necessary?
Because you have to have something reflective. When you make one in the house, the rainbow produced will take the shape of the reflective surface.
All right. Now, what did you say about triple rainbows?
You can't have those. Not possible.
Not possible, you said. All right, just a second here. When I do this, you could have done it yourself, but all right. There you go. There's a triple rainbow.
What?
Yeah, there's a triple rainbow there. Just let's see here.
I think you might want to check your sources because there's never a rainbow in between that space.
But I mean, clearly there is right there. We're looking at it.
You see NBC right there? There's your clue.
Sorry, denialism isn't actually evidence. There's three rainbows right there.
No, there's not. There's never any rainbow in those space.
Well,
on real rainbows.
I mean, except right there. The screen doesn't actually make it go away.
But saying that there's three.
But everything you showed me was on a screen.
Okay, so
right?
let's see this. Okay, so you're saying that there is a rainbow inside that space. Okay.
Yeah, right there.
So we have videos of real rainbows outside. Yeah, from an NBC source, not from a mainstream media source, but none of them have that rainbow. How is that possible?
Well, I mean,
how is that possible?
I mean, we're looking at a triple rainbow right now. So,
but how is that possible?
Again, it's.
I'm telling you how it's possible because we live inside of an enclosed system.
But Marissa's right there. So, you're looking at a triple rainbow.
You see this right here, this NBC?
It doesn't make it stop existing.
It doesn't make it exist either.
Make it stop existing.
Show me a real photo.
That is right there on the screen. Real photo.
No. Scroll down, please. Scroll down on your screenshot.
Oh, look at that. There it is.
No.
Yeah, right
Go back up.
there. Look at that. That's lovely.
That is absolutely not possible.
Oh, well, I mean, except you're looking at it.
Do you see it anywhere in nature like that?
Yeah, right there. We're looking at it.
Or is it
It's on
just that one example?
Yeah, right there. Oh no, that's not the only one. Here, I'll let's see. I have this one here. You see, I mean, you could have just like looked it up yourself and made sure that you weren't just talking stuff that's nonsense. There's another
only
one.
two.
There you go.
There's only
so
two.
there's three. I mean, we're looking at three right now.
I'm looking at it's not possible.
So you say, yet we're looking at it right now.
But these are just like, do you have video of these?
It's a moving the goalpost there.
No, I'm not.
So there's a double,
I'm just saying,
single double.
See?
And here is, for reference, this is how the light
Then make a rainbow in the
travels.
house
Yeah,
with just water alone.
Move those goalposts there. So this is
Then
the problem.
No, I'm just saying.
Marissa,
You're saying that.
You're
saying that rainbows.
I want to
There's
get
three
serious.
rainbows that are possible.
Marissa,
Yes,
I want to get
do wanna
serious
be
for a
serious.
second here.
All right.
I've let you talk an awful lot, and I've
Okay.
I've certainly enjoyed, this conversation. But just
Do you see
saying
this
it's
right
not.
here?
But just saying
I
it's not
want
possible.
to talk about your
Well,
thing that's on the screen.
I wasn't even done.
A
Marissa.
triple rainbow will emerge for a brief period of time when it's 40 degrees from the sun and clouds. To produce a rainbow, light must be at a 42 to 45 degree angle. So that's not possible.
Yes, a single rainbow, correct. A double is different. Each order
How is double different?
of rainbow has different angles that it comes out.
That's why it's not possible to make one in the house with water alone, because water, it's not capable of doing both refraction and reflection simultaneously because they need the angle.
It's not simultaneous. I mean, you're looking right at the picture there where it's not simultaneous. It's in different locations.
Well,
So-
then make one in the house.
Hurry up! Come on!
With just water alone. Water and light. That's all you get.
It's a
Water and light. That's all you get.
I mean, what that's called is a classic goalpost move, or also a unicorn hunt. That just like I've asked you specifically,
Or that's how
Marissa.
rainbows.
I've specifically asked you if you would accept
hurry
something.
up! Come on!
Hold on. I've specifically asked you if you would accept something, and then you said yes, and then I showed it to you and you
Sure.
rejected it. That's actually being dishonest.
Because it's not
So-
possible. Do you
All right.
see them outside, physically outside?
Look at that
Do you
right
see
there.
them?
Right there. You asked for a
That
video.
is not possible.
So you asked for a video. I'm showing you a video, and now you've made yourself a liar, Marissa.
No, I haven't. It's not possible.
But it's there. We're looking at it, Marissa.
But I think your video is edited because that,
because
that's not
you've
even-
pre-selected a conclusion, and 688 people just watched you lie.
then
live.
how is it possible?
I'll show you the diagram again. It's right here. That's how it's possible. This diagram, inside of the droplet of water,
Okay.
as the light enters, goes
we
from
should be able. Then
goes
we
from
should
the-
be able to turn on a light in the. You can make one with the water hose, right? You can flip the light, whatever. Like you can make one with the water hose outside. Outside, I have air, water, light. Something reflective is surrounding us. We get a rainbow anywhere.
The reflection happens on
Inside-
the inside of the water droplet, Marissa.
Inside, I have air, water, and light, but no rainbow because there's nothing reflective. The dude that you're talking about, making a rainbow in his garage with the kids, he's got a metal ceiling.
Okay, but
It's
here,
reflecting.
Marissa, you see, here's a diagram. I've provided a diagram of how the light refracts,
No, you've
refracts and reflects.
provided what
And-
the mainstream
and-
media has said to you.
Yeah, and
You're just parroting.
you've not actually shown how it's incorrect.
Because light must refract and reflect
And
to
that's
produce one.
And that's what we're looking at right there on screen, is showing where it refracts and reflects.
But you need the angle.
Yes, and it shows the angles in the diagram too.
No, you need to be at a specific angle. Whenever
To
you're
view it,
looking at
yes,
something.
yes, you do, of course,
Right.
yeah.
So
I showed you a
it is.
picture. I showed you a picture of triple rainbow. Then you said, "Where's the video?"
Then
and I showed you.
reproduce them.
Then I showed you the video. See, this is called
reproduce them.
unicorn hunting. You
We are
you
trying.
say, Marissa, you say that you want something. I provide that exact thing for you, and then you move the goalpost because you're dishonest. And I'm showing you
No,
right
I'm
now.
moving.
You're
No,
moving the
I'm
goalpost.
telling you.
673 people are watching you move the goalpost again.
Okay.
You asked for a video. I gave you a video. You say no when I gave you a video.
In your
you
video
do
right
not
here.
because
Hello?
you do not care
Wait a
about being
second.
honest, Marissa.
In your video right here, why are these the same direction in your video? Why are the
Why are
rainbows the same direction?
I don't
The
know.
colors are the same direction
You asked for a video. I gave you a video.
because it's propaganda. It's like you're the guy in the garage. All of these rainbows, the colors are in the same direction. That is not an equal and opposite rainbow. It's not possible. Your picture's fake.
So you say. So you say. All right. Because it must.
It's
It must.
not
but okay.
possible. When we see equal and opposite double rainbows, they have
Sure.
the opposite. It's
Sure,
not
okay.
red, red, red,
All
blue,
right.
blue. You see
right.
what I'm saying? It's not possible.
I see what you're claiming. I see that you've got a lot of denialism, and I'm used to it, Marissa.
Okay.
I get a lot lot of denialism here, and
We
and
get a
very
lot of
often,
denialism from you guys too, because
very
it doesn't
often
matter.
I
It
get
doesn't
somebody
matter
that
what we say.
I get somebody that plays the unicorn hunting game, and it's the results are typically
I'm
the same.
telling you to
So,
do experiments.
yeah. Well, it's your claim. You have the burden of proof, not me. When you have a
My
something
burden
like that.
of proof is 360-degree equal and opposite double rainbow. Show us the outline
just words.
of the sonoluminescence bubble that we live inside of.
Yeah, that would be, that's your burden of proof. All right, well, I've got a bunch of questions and interaction from the audience. I'd love it if you stuck around. You probably won't like a lot of these questions, but feel
That's
free
fine.
to, all right.
Well, I didn't even get to finish my model. Like I wanted to tell you like how the sun and moon move, because once you do those poles, then the moon is on the inside going west to east. We see that whenever eclipses, the moon comes in from the west. The sun is on the outside of these fields where it's going east to west. It's attracted to one field and repelled by the other, giving us the longer and shorter days and the summer and winter solstices. So the sun, moon, and stars rotate like the tangent vectors of a bar magnet.
Okay. Do you have, is there a map associated to this?
Yeah. Hold on. I'll show you.
Man.
See if I can.
All right. Got Judy Bassett said, "Good grief, good night." I don't know if that was it. That's all that she could take. That was 13 minutes after we started.
Okay. Well, some people can't handle it.
The Sun Express says, "Going with ancient Middle Eastern mythological nonsense is not a rational position to take if you don't understand something. Why is our planet not allowed to be a sphere?"
Because the ground would physically have to curve.
Check. Measured. All right.
No, you don't.
Many Karen says, "Outside a vacuum chamber, air resistant makes things fall at different rates. Therefore, we use a vacuum chamber to isolate gravity."
Well, then you need the Cavendish experiment in there too.
It's been done. Yep. And that was another unicorn hunt that we went on. It's been a lot of fun unicorn hunting.
Well, I'm not
All right.
telling you. I'm not saying believe me. I'm saying consider what I say, and if you want to stick with the globe, stick with the globe. I honestly, it's like it affects me zero, really. I'm not doing this for anybody else but me. Are you seeing this? Are you seeing my share?
So you've got the azimuthal equidistant projection from the globe, as described in the patent.
So don't pay attention to like where the land is right now. This is just a diagram of where I think it is, because the moon on the inside, it gains and loses its light through an electric arc as it comes closer to this magnetic field here, this positive magnetic field, because the
why
moon
is
is
Sirius
negative.
in the middle?
The dog star, Sirius, is in the middle because it's a binary star, and if the center is made up of a horseshoe, then it's the binary star. You see how it's made up of a horseshoe? The binary star Sirius is in the center, and then the Polaris, when it connects with the positive water in that inner membrane, it creates a spark, so we get a pole star. So the moon is on the inside of these fields, going west to east. It gains and loses its light at 7% each day as it comes closer and progresses to this positive magnetic field.
Wait, it's
The sun,
what the 7%? What's the 7%?
the moon gains its light at 7% each day. That's why, like in the middle of the month, the 14th of the month, it's like full.
Oh, it
'Cause it's
doesn't.
got a 28.
It's a linear, not a sine cosine type relationship.
No, the sun and moon move over our heads in a circle, and the way that we can tell
No,
that.
I was talking about the luminosity, the brightness.
What about it?
I just, I was under the impression that it was not linear.
No, the moon gains its light at 7% each day.
So linear, okay.
It has whatever you want to say, but it gains and loses its light as it progresses 7% each day on this field.
And what
Around
and
the
what
circle.
what keeps them up there?
The magnetic field, they're magnetic. The sun is positive. We rarely see a sunset without clouds. The moon negative. Most nights are clear, they pass quickly. Like they are locked in perpetual magnetic motion around those fields.
But I've seen plenty of sunsets without clouds.
Rarely.
Right.
Water's diamagnetic. If water's diamagnetic and the sun and moon are magnetic, they're gonna be attracted and repelled by it. Just like at your poles, you should have some evidence there. My point is that I need to verify how the stars move over the UK so that I can triangulate and find the actual location of this pole. So I'm telling both models that they have not found the location of the poles. They cannot tell any evidence of why it's there. So we need to find the poles.
So the people who, like, it's their job where they go out from New Zealand to measure the actual location of the South Magnetic Pole, you know better than they do about how they do their job?
Well, what are they using?
I don't know offhand. Yeah, but there is a group of people that
Even on the
from New
globe
Zealand
model,
go to measure the location of the South Magnetic Pole every once in a while.
So you're saying the South Magnetic Pole is like right here?
Well, if you have a cursor, I can't see the cursor on your screen.
Okay, never mind.
But the South Magnetic Pole is between Australia and Antarctica in the water.
So the South Pole is now in water too?
The South Magnetic Pole, not the South Geographic Pole. The South Geographic Pole is in Antarctica.
Wait. So how are there two different locations?
One is the
Because
magnetic
I thought the pole, right?
Yeah, one is the
That's supposed to
magnetic
be
pole.
going through your globe has to be there has to be an inflection point down there at the bottom, right? Where's that? Is that on the ice or is that in the water?
So I'll say it again. The South Geographic Pole is the axis through which the Earth rotates. And it comes out the north and it comes out the south. And that's at 90 degrees north latitude, 90 degrees south latitude.
Where is that located?
90
and how can you tell it's there?
90 degrees south latitude. The people can do it using celestial navigation. You can use GPS now. It's much easier than celestial navigation, but you can use celestial.
GPS is ground-based.
Oh, well, except it's not.
Except it is.
You can get it in the middle of the ocean. You can get it in airplanes over the Yukon territory.
Because they have satellites out there too, or they have like ground positions out there too.
They have satellites.
Yeah, they have, like, in the middle of the ocean, they have those little buoys that have, like, satellite receivers on them.
Satellite receivers?
Yeah, like...
I mean, are you
like,
misspeaking when you say satellite, or do you think that there's satellites orbiting the Earth?
No, there are no satellites orbiting the Earth.
Okay, but you...
Are you kidding me? You can't get out.
I didn't think you meant that, but I was just clarifying because you've said satellite a few times.
The receivers like we have, like, for our cell phone, those receivers,
Yeah.
they're in the middle of the ocean too. They're using solar panels.
So you say. But
Yeah,
what about if you're in an airplane over the Yukon Territory?
Same thing.
Where?
You have to be in the direct path to get the signal.
Direct path of what?
The signal, like the signal that you're trying to get, like your Wi-Fi signal or whatever.
Yeah, but
all of those, light travels in straight lines, microwaves travel in straight lines. All of them travel in straight lines.
Okay.
That's why I put the sun like that, because light travels in straight lines and diminishes with the laws of inverse squares.
It does.
So I put the sun like that because, like, there are no south pointing shadows.
What do you mean south pointing shadows?
The shadows go east to west. There are no south pointing shadows. When the sun is over here, to have a south pointing shadow.
What the hell even is that?
Are there any south pointing shadows?
Yes.
Where?
When you're south of the Tropic of Capricorn, you see south pointing shadows.
No, you
Midday. No, you don't. You just hand wave deny that.
Because light travels in straight lines.
1 billion people live south of the equator, and they all can see south pointing shadows at different times of the year. And you know better than 1 billion people whether or not they're able to see south pointing shadows. Is that it?
Mm-hmm. Because light travels in straight lines.
Marisa, you understand
the laws of inverse
that
squares.
is absolute insanity for you to make such a bold claim like that. 1 billion people you just said are wrong because of whatever words you said. That makes no sense, Marisa.
Hold on, I'm getting to it.
No sense at all to say.
Okay. Oh, I gotta stop sharing that. I'm sorry, I didn't know I was sharing that. Share. Okay. Do you see that?
It's coming up.
Light travels in straight lines, and when
I generally yes, unless there's something reflection, refraction, or gravitational lensing.
Light
then yes.
travels in straight lines and diminishes with the laws of inverse squares. That's how shadows are produced. That's why I put the sun the way that it is, because there are no self-pointing shadows. When the sun comes up from the east, the shadow points west. When the sun goes down in the west, the shadow points east, and it points north all the way through the day.
But Marisa, shadows point south.
No, they don't.
Yeah,
there are no south pointing shadows.
They
no,
actually
they don't,
do. They actually do, Marisa.
Because when there's supposed to be a south pointing shadow, the sun is too far away because light diminishes with the laws of inverse squares.
What's the law of inverse square?
This is the law of inverse squares.
Yeah, Gareth Bunting is unclear what the law of inverse square means. So at noon in Sydney, Australia, at noon in Sydney, Australia,
this
shadows
is law
point
of
south.
Inverse squares. No, they don't. Do you see this? This is the laws of inverse squares. When light travels in straight lines and it diminishes with the laws of inverse squares. And
okay.
Hold on, let me see if I can give you a better.
You're generally correct, yeah.
Let me see. What's that other one in here?
All right. Are you near the end of your model?
Yeah, I'm trying to show you why I put the sun and moon like that, because the light travels in straight lines and diminishes with the laws of inverse squares. That's why. And there are no southern pointing shadows. Otherwise,
we've got right here. B. Falconer says, I've been in Sydney, Australia at noon and the shadows point south.
then these should all read the same time, right?
We're looking at your eggs, your Easter eggs there.
You're looking at my what?
The little Easter egg thing, whatever that is, with the measuring tape underneath it.
Oh, that's the how it spreads out with the laws of inverse squares.
Yeah.
When light spreads out into the area, it diminishes. So that's the laws of inverse squares. So when the light is on the other side, it cannot get that far. There are no southern pointing shadows.
All right.
So that's why I put the sun.
All right. Well, Marisa,
the way that I did.
Here's what I'm going to I'm going to move on to the questions from the audience. I have to say, yeah. Tommy,
I'm
you're
saying
right.
that.
So, okay.
I'm saying that the sun, moon, and stars rotate like the tangent vectors of a bar magnet, not a pole and axis.
Yeah, so you say. All right. Chris Kelling says, who is this they, and what experiments for spacetime?
I don't know. Space-time, whatever. I gave up on that a long time ago.
All right. Halsoy says, maybe study that which you want to refute, Marisa. That's good advice.
Maybe they should.
Always good advice.
They should as well. Maybe they should as well.
Definitely they should. Turing Test 2 sorry, says, kudos to UMC Tune for all the patience. I'm not a doctor. It's patience, like long-suffering synonym. Kentucky Jerk says, being a Kentucky native, I love our bourbon. Being in my 40s, I have cut back and now drink red wine. She made me want to sit down a fifth of Knob Creek.
Dude, down it.
Down it.
Stay in.
Kentucky
Whatever.
Jerk, bottoms up, buddy. The whole thing. Shovelhead Steve, that was a little bit much. Peachy Tony says, this is not a frivolous comment. When was the last time your guest had a mental health assessment?
I could ask the same question about y'all. You see 360-degree equal and opposite rainbows, but have no way to explain them on your model. Besides water alone.
The really good explanation we have. So
Water alone, but you can't
millions
make one
of
in the
people
house
literally
without
have
it.
jobs depending on gravity, but sure, it does not exist. And isolate gravity on Earth?
What's the difference between that location and this location?
I don't know. Nikkei
Things
Spitz.
float.
Nikkei Spitz says Marissa is just very, very uninformed.
Well,
So-
they can choose whatever they want to believe. I am not doing this for anybody but myself. So I've come to your audience
All right, Marissa,
to ask for
you
some help.
you don't have to respond to every one of these. They're not going to be. All right, you don't have to. All right.
Then why are you reading them to me? Why are we here?
Said you don't need to be here. Like I said, this is the optional portion of it for you. They're
Okay,
they're
well,
going to be
let me
very
finish.
critical. They're going to be very critical of you.
Well, let me just finish, and then I'll go, and you can talk to your audience.
How much longer? Can you give me an estimate?
2 minutes. 2 minutes.
All right, 2 minutes. All right.
Okay, so the things that I need, I'm coming to ask your audience for help. I need to verify that Star Trail video. So I need somebody from the UK to send me a time-lapse video from the UK so I can verify which location it says, and then I can triangulate to find out the rest. But I'm going to give out my email address. If you're going to send me something, then don't send me something like just you're wrong and send me an article. You should be able to tell me where I'm wrong
I'll
and maybe
back
a
you on-
suggestion.
if I can say, people,
Can I finish, please?
please do not be rude when you send emails. Don't. If you have something to say, don't send her an email on
Right,
it
and
if it's
then
rude.
don't send me those pathetic attempts about trying to make a rainbow in the house, because they're only fooling the people that don't know what they're looking for. Like, don't send me the one with the guy in his garage with the metal roof. Don't send me the one with the black background and you got that black pot in front of it. You can see the reflection of the pot in the mirror that's painted black. So don't send me that one. And then there's one with some dude in a basement with a spotlight. There's a metal strip like right there. Don't send me those. Like, if you're gonna send me something, then be able to show me at least. And or
Right.
if you just want to
You're
send me
getting close to
that,
the end of the 2 minutes.
right? So if you just want to send me an email saying that you might have changed your mind, that's fine too. But my email is mkeeland02@gmail.com. So if you want to get in touch with me, that's how you can do it. But anyway, I'll say goodnight. Those are the things that I need. I need someone to verify how the stars move over the UK.
All right.
And
Marisa?
if I'm correct, you can go outside and check your stars. And if they move in straight lines and you're in the middle, then there goes the globe.
All right. Well, Marisa, thank you for coming.
Thank you for having me. I appreciate it.
It's been a ride. All right. We'll see you. Thank you.
Bye-bye.
Okay. All right. And she is out. Yeah, Tommy. It's all right. So it's clear she's not dealing with all of her facilities. So I didn't know coming in how far out she'd be, but wow, she was out there. But let me be very clear. There are few flat earthers that I've ever talked to that were not definitely mentally ill in some way. And as we'll see in the next stream, there's some severe stuff. And Marisa probably is just kind of a little bit of in a bubble of her own, and probably doesn't affect a whole lot of other people. But some of them go out and stand on street corners and proclaim things. Some of them try to shut down NASA. Some of them can't not just, keep to themselves. So things like, none of us would care if they didn't go out there and start trying to tell everybody that they thought the earth was flat. None of us debunkers would have anything to debunk if they just shut up. So when people are like, oh, how come you can't just let people believe what they want to believe? How come they can't take their beliefs and just not try to spread them to everybody? You see, if you're going to get out there, you're going to have to deal with the ramifications of it. All right, I got a poll. I don't even remember what the poll was now. Is she actually a concaver? Yes, 54%. Turns out she's not. I was thinking she was heading that way. So, all right. Well, she's not here, so I can be a little more forward on these things. Tim Pryor says, why don't you guys ever demand flat earthers to give you the same proof you demand from us? Well, yeah, I mean, because it wouldn't go anywhere. It would instantly end. No flat earther has any evidence for anything. So, Cretan Bull says, is it too late to nominate someone for top left? Yes. Halfway Crook said, my house almost got hit by a drive-by wrecking ball. Good thing the house is bigger next door. Oh my gosh, she really didn't understand anything. Hate Stairs says, Toon, stop scaring her with logic and facts. I see Spin says, incompetent overestimate. Experts underestimate. Yeah. Dear. Pat in the chat says, what rolls downstairs? Oh, I already did that. The law. I love that. What rolls downstairs alone or in pairs all over your neighbor's dog. What's great for a snack and fits in your back? It's log, log, log. And that's from Ren and Stimpy. Charles Ronham says, ask her how she would account for the water content of the wood, water being a diamagnetic. And that was a long series of unicorn hunting. You know, it has to be she said it has to be in a vacuum, where it is in a vacuum. Well, it can't be made of metal because metal is magnetic. Everything is magnetic. Ferromagnetic, paramagnetic, diamagnetic. Everything is. Then it's impossible. No, it's not. You can demagnetize things. She didn't know what a hysteresis curve was. She's not qualified to have an opinion on the topic. Lael says, classic flurf. I have such and such, but I did not prepare my stuff for your debate, so I can't show you. This wasn't a debate. To be fair, Lael, this was her. I asked what she wanted to do. It was going to be a debate, and then she was like, I just want to explain my model. Okay, well, you have a model. That sounds great. It turns out it's the craziest one so far. Why does the star need to be binary? Don't know. Why do you just hand wave blanket deny that Polaris is a binary star? Don't know. Why is Polaris over the Eye of Africa? Don't know. Why is Sirius in the center of rotation? It's not. Don't know. None of this made sense. Clearly, she doesn't have a grip on reality. Indy's Tiger's Sci-Fi Review says, Galileo used ramps and balls of different materials to prove that objects are attracted to Earth at the same rate. No vacuum chamber required. Certainly, that is true. That's how he did it. Baux1 says, I didn't realize Walmart sold science degrees. I could not stop hearing Melissa McCarthy's voice. It was like, it struck me. And then from then on, that was the voice I heard. Keith M says, ask her about the Cations and Anions. Hey, I brought them up. Trainers one says, they're hiding the West Pole from us. Dare Ick from TikTok wondered about the West Pole and the East Pole. Oh, jeez. Pat in the chat says, does she expect a barbershop pole at the pole? See, she has such a misunderstanding of how things work that she watched that video that I think is just there's these videos that people make that are just like they're faking things. So that magnet that was underneath, I think is just part of the fake to make people think that it's part of the deal. And then she just showed an electrolysis and she thinks that that's supposed to be what happens in she thinks that's what's supposed to happen in the ocean. Electrolysis should happen in the ocean. No, none of that was the magnetic field. Jeebus, the binary star is in the center above the horseshoe magnet. Made no sense. Timo Lynch says, Marisa for top left. Many Karen says the entire channel wishes to apologize to Mark Wright for calling him dumb. Perspective has taught us a lesson. Oh, many Karen. Oh, so many levels. So many levels. Industrial Nerd says the only question that matters, which way is down? Mikey Riot says, guys, this is why we stay away from crazy eyes. I don't know why her eyes were like that. Eddie Reese says, Snell and Snellen, two Dutchmen without whom Toon might not be able to see his computer clearly. It's Snellis, right? Keep doing it wrong. Bill McGuire says, imagine devoting yourself to months of study only to come out exponentially dumber. She put up a billboard in, what'd she say, Oklahoma City? In 2016. She's been this for 2016. Matthew Pip. Hey, buddy. Was wondering if you had any evidence of the sun going straight across the sky at the equinox, at the equator on the equinox. the last video you sent me did not show that required on globe. Oh, Matthew Pip. Standard unicorn hunt. Followed by denialism. Bhakti says her model is nope. Yeah, definitely. Minnie Karen says, yes, Marissa, sodium is a salt. No, it's not. Antarctica is made out of it. No, it's not. I see spin misunderstanding does not equal discrediting science. I don't know if I've talked to somebody that has a more incorrect view of how science works, about how things work. Strangers one, if time didn't start on time, how would we know? Stringfellow Hawk says, Marissa, you have 2 ears and one mouth. It would help if you'd use them in proportion. Listen to MC Toon. He knows what he's talking about. Well, thank you for that. I don't think she was interested. She is not interested in learning. She has everything already figured out. Didn't you hear it? She thinks she is smarter than Einstein. She did. It was completely unaware to her that the claim of the globe is that gravity keeps air in, not electromagnetism or magnetism or geomagnetism or just magnetism, because I don't think she knows the difference. Mark Beiser said, let's get to her unified model of derp. It did. It's the horseshoe under the ground with the Cirrus, the only, according to her, the only binary star. Sorry, Marissa. Polaris is a binary star. Nuh-uh. Like, could you just be a little bit more like, oh, maybe that's not right. So she pulled up the Wikipedia page for Cirrus. Not somebody in the chat said it was 5, and that's what I repeated. But the Wikipedia article, I pulled it up while she was talking on Polaris, says it's a binary star. So she won't accept that one, though, because she's pre-selected her conclusion. Anything that contradicts it is automatically wrong. Minnie Karen, how much model could Marissa chuck if Marissa could chuck models? Janusz. Takas. Takas? I don't know. I'm sorry. Says, please ask her what the dot product of 2 Cartesian angles on the complex astral plane. Oh, she took calculus. Cheshire Cat, does she know that you can get a job in Antarctica? Certainly she's pre-selected that it doesn't exist. Indie Tiger Sci-Fi Review says you need an anode and a cathode. And The Road Ode by Karen and Richard Carpenter. Verillion says this is Nuckin' Futz. And I see Spin says, what's the value of C in the equation E equals MC squared? I did kind of ask her that. She's like, how she didn't understand light. Like how fast it, like she wanted to accelerate or something. Mute Dog, yes, you're right. I do think that Polaris is a trinary. I had the astronomer on a couple months ago where he talked about it. So I don't know. I'm not really up on the details of stars like that. But if you're interested in how to measure the distance to stars, Eric Burns was on my podcast. We went over it. It was great. Eric did a super job. You'll find that one on, just search for Toon Show if you haven't already subscribed on YouTube, or search for The Toon Show. Yeah, they don't match. On your favorite podcast. The podcast is audio only on Toon Show, the YouTube channel. You can see the actual video of it, and he actually had some presentations you could see. So really cool. Our T96, does superheated sound lose its magnetism? Oh my gosh, she thought that. I mean, Witsit thinks that sound is electromagnetic. He's said that. This week, he said it. Mouth Breather says, what language can Rice speak and comprehend? Certainly not Vogon. Tommy Groundwell, wow, just wow. We've got Javier Portillo Fernandez says, Sanpaku eyes. I don't know what that word is, so I hope it's not too bad. I didn't say something over the top there. They fear it. It's bad to be the second name of something. Nobody calls their motorcycle a Davidson. And now poor Morley is Mitchell's son. She's an expert on Michelson Morley, knows more about relativity or more, is smarter than Einstein, but doesn't even know the names of the people that did the experiment that she never read the paper for. She's going to bring it up, a video of it, because she wouldn't dare bring up the actual paper. She never read the paper. And instead she brought up one showing the Sagnac effect, confirming that the Sagnac effect can measure rotation. Shot herself in the foot there. Luke Filewalker says Earth is flat because of double rainbows. You heard it here first, folks. Many Karen, equal and opposite rainbows, me and a lesbian. Kira says, how reflective does a surface have to be to form a rainbow in a room? And that's why I kept asking for the diagram. Of course, she couldn't provide it. It makes no sense. Why would a reflective surface make a difference? Did it go into the water droplet, refract, bounce off of the surface, the reflective surface, and then come back through? Or did it go off of the reflective surface and then go down into the water droplet and then inside the water droplet reflect internally? Well, it can't reflect internally, she thinks. I don't know. Makes no sense. Kira says, how reflective does a surface have to be to form a rainbow? Okay. Pat the Chat says, I feel we need to crown a top left queen to go with the top left king. You make a good point. That there is no competition. She thinks she's smarter than Einstein. So does Whitsitt, right? Whitsitt literally thinks he's smarter than Einstein. And neither of them are correct about anything. So Eddie Reese says she's not going to send it to you later. I know, of course she won't. And a yes, it was your cube. Oh, God. Sid Allman says, anytime MC2 asks for the math, every flare freezes and has a look of terror on their faces. Amazing. No doubt. I've never seen a flat earther really, well, no, let me say, there's a couple that can do math. But they don't go around claiming that they did math generally. They're smart enough for that. Charles Renham says Polaris identifies as non-binary. Tommy Gronwald says far out, man. Far, far, far out of here. Yes. Serena's one says, has Marisa seen God's shoes? Asking for Al Bundy. Oh my gosh. 2D Rescue explains stuff, says, I sent you 2 super chats as Charles Ranum. So here's more money to call me 2D Rescue explains stuff. Well, thank you, Charles Ranum and 2D Rescue explains stuff. Baux says, quick, someone please, Baux1, please tell me the safe word. If you've seen Eurotrip, it's in there. That's the safe word. You're going to have to go pull it up. Joe Don says, her model is built on incredulity and fundamental misunderstanding. That perfectly describes it. So why does she think that triple rainbows don't exist? Why is the double rainbow something? Why is there space between that has meaning? None of the sonoluminescence stuff makes sense. Icy Spin says, number 1, Flurf citations always contradict Flurf claims. She didn't have a lot of citations that were non-Flurfy, but yep, that's true. Russell Flagg says, Flat Earther, that's not how Earth works. Or that's how Earth works. Globe Earther, that's the dumbest crap I've ever heard. Marisa, hold my Kool-Aid. Thank you, Russell Flag. That was his first super chat ever. So thank you. I'm glad I could pop that bubble. Charlie Welch is from Oklahoma all the way to Titicaca. Oklahoma. Oh, geez, yeah. But the Sun Express says Marisa, a late entrant for top left. I don't think she's going to be doing a whole lot of more stuff. I mean, she wants to find people that, I don't know why she can't even fathom that it's really not that big of a deal that somebody at 49.5 degrees north latitude saw that video of the star trails. She's so confused. Serena's one says 3 cheers for non-binary stars. Jeez. Humphrey Pushcart for $10 says, Holy Lake Titicaca, Batman. Marisa is a charming example of misunderstanding with confidence. Alas, Dunning and Kruger have a new poster child of ignorance. Yeah, the Sun Express says, please ask Marisa about the Cations. I did bring it up. I did. IC Spin says, too, and for your information, Microsoft invented hearts in the 90s. No, they didn't. No, they didn't. I do believe that the game Hearts has been around longer than since Microsoft put it into their program. And I says, I bet she gets confused when someone uses a laser pointer. I don't get it. So far. 2 positives doesn't spark. Question mark. Put together a 400 volt and a plus 300 volt wire, and there will be a spark. Probably a bang and an ow, too. Yes. So that was from Janosch. Icy Spin says, how does a metal ceiling above cause a rainbow? Completely unexplained. No explanation offered at all. She just all, and she kept saying it. Reflection and reflection. Refraction. Oh my gosh. She broke me. Reflection and refraction are both necessary. True. Where do they happen? Where does the reflection happen? Where does the refraction happen? She has no clue. She has no damn clue. Fact-based says, DFOTY wildcard latecomer. She is delusional of her scientific knowledge, her intelligence, her ability to think. Girl needs to grow up and stop pouting. Kudos for coming on here, but wow, that was a show for probably the most crazy. I don't know, has any been more crazy? Right? You've got her, you've got Flat Ferdinand with the bzzz, if you haven't seen that one. Who else is crazy? Like that kind of crazy in the realm? I don't know. Chris Kelling says, I would like to know what she thinks a prism does. And she actually sort of described it. It slows down the light. When it enters the medium, it goes slower. See, Mallory doesn't count. And I've not had Lindsay Harris on. Jin CBR1, no, he just parrots everybody. She has stuff. This was a brand new flavor of stuff. Psalm? Oh yeah, Psalm. Different. The numerology homo is similar, but is a similar kind of crazy. Yeah, that's Ryan Casey. All right. Tommy Granvold, where did she do her research on this? I have no idea. Sarusani has been a member for 1 month. Says only know Bob Morley. Mitchelson Morley and Bob Morley. Sean O says, please tell her she sounds very, very expert. I did. She was happy to hear it. 2D ResQ Explain Stuff says, will Flurfs ever debunk the national debt? Tell you, if you could harness the power of denialism from her, the debt could be erased. That's how powerful her denialism is. Larry Scott says she's hilarious. She was. She got a little sensitive, and I didn't try to get that, but I'm like, you don't just get it, because this isn't your soapbox, right? You're gonna come here and start talking. You're gonna have to take a little heat. Gary Little says squirt is a drip under pressure. X is the unknown quantity. Expert is an unknown drip under pressure. Good Gremlin Media says, should we tell her? Oh, tell her what? There were too many things. There were too many things that she got wrong. The Imaginator creator says, I've been waiting and waiting, Marisa, but you still haven't presented your model. Where's your model? Yeah, she actually used the flat Earth map, the azimuthal equidistance projection from a map, actually from the globe. She actually, if you looked at it on over the where it says the word projection, right here it says projection on the map. She had an X over where it said projection. Oh, all right. Kango44 says, does Marisa think we might need to know a bit how light works to build her webcam? That's the thing. Like all of the technology. She's like my this book on electromagnetism. She just wants to throw it out. But how is the computer that she was talking to me on? How does that work? It's in here. The foundations of how that computer works are in here. Clearly, it's not just crap. She just doesn't understand it. String News 1, Witsit is her flurf daddy? My guess is she has no idea who Witsit is, probably for the best. If you wanna get her going after somebody, Sam would be a good one. Trey, people talk Trey. I think she might really like Treycation. So Round Ball Defender says she's not even smarter than a 5th grader. Sorry. Good Gremlin Media, says the irony of her calling Einstein a moron. And true. And most flat earthers must have that position. Many are wise enough to not say it. But I think almost all of them think it. Luke Fileworker says, how deluded do you want to be? Marisa, yes. Oh yeah. My mom bakes cakes, says she is electric. She thinks that electric eels get recharged by going into somewhere. Oh my goodness. Cynthia Merritt says, when eyes widen, she's thinking her Nobel speech. I can't wait for her Nobel speech acceptance, Nobel Award, Nobel Prize acceptance. I can't. I need more. Hold on. I'm out. I need to top off. Great. Toads in My Eyes says the Michelson-Morley experiment disproved luminiferous ether, and of course it did. And for the flat earthers, they don't get to both cite Michelson-Morley and Michelson-Gale-Pearson or Michelson-Gale, because if they claim that Michelson-Morley measured that the Earth is not moving and that the ether is not moving in relation to the surface of the Earth, and Michelson-Gale measured a rotation. So what is it? Earth stationary, ether stationary, or Earth stationary, ether moving. You can't have both. Pat in the chat. Mainstream media. This is so silly. She's insane. Oh my gosh. And people, there's so many chats here. Blade Relic says, thank God the Earth is flat. It makes it easier to move the goalposts. That's Blade Relic's first super chat. Thank you for that. Yeah, rainbow propaganda, says Eric Burns. Oh, I'm glad you're still here, Eric Burns. Listen, people, Eric Burns did a fantastic job. He's in the chat. Go watch on Toon Show his presentation on measuring the distance to stars. It's completely the opposite of Marisa. Sensible, used evidence, applied math. It was fantastic. Absolutely fantastic. Eddie Reese says this was fun, but she never presented a model. She tried. It's this one with a whole bunch of weirdness, you know, stars in the wrong places and whatever. Luke Filewalker says, I can make rainbows with water in my cellar. No problem at all. Ooh, sorry. It would be, and I know some people said that they messaged me. And I see I see a bunch of messages right there and some emails, I'm sure. So I'll look through to see. I would love to see multiple different rainbows inside, to just, you know, to go after when they do that that hunting. So, and Tommy Gronvald, all right. So Tommy sent me a message on Discord, and he said, "Will you please address attacks on physical appearance?" And so, yeah, okay, her eyes were right. Anything other than that, I think you guys don't. That's not cool. Like she said, she was paralyzed. She is a paraplegic. So, you know, things happen from that. Be kind. So, and same thing happened with Mark previously. People were talking about some stuff they shouldn't have been talking about, and I was fortunate. I was in the chat. I could pay more attention than here. About I'm not even going to repeat it, but I mentioned it. It's okay. We can enjoy a chuckle at some of the derp, but you know, physical appearance, no, we don't need to do that. Okay. There it is. Icy Spin says, I emailed you an ELA analysis of rainbow source image. Thank you for that. I'm certain she will be completely swayed by the analysis of it and decide that, yep, triple rainbows do exist. Do you think that she's actually going to go, you know, to her browser and start Googling triple rainbows to actually find out if they really do exist? Of course she won't. It might break her pre-selected conclusion. So the rabbit says, I challenge MC Toon to make the most hippity hoppity flat or concave earth rap song with the bomb lyrics. Well, I don't rap, so it'd have to be somebody else rapping. Glober Mom says, why does Marisa have to be right? Seems to me her mind is closed to any evidence that goes against her narrative. In fact, that's definitely the case. It's all flat earthers like that. Oh yeah. Bob says, concerned. I think she's exhibiting signs of mania. Yeah, something. Don't know what exactly, but yes, something. Joe Dunn. I was trying to be, you know, not push it, not mock her about that. So, Joe Dunn says, how can Polaris be over Australia yet never be seen from Australia? That's a good challenge. And how can you just handwave deny south pointing shadows? It's like she invented this necessity and just won't like even think that maybe 1 billion people have seen that happen. Well, more than 1 billion, but 1 billion people currently live where they can see it most, you know, portion of the year, and everybody south of the Tropic of Capricorn can see it every day of the year. So Keith M says, I did a good job not mocking. Well, thank you. I some of these people, right? Ryan Casey, he's out there, but look, I've asked him, hey, do you need help? Do you need money for a place to stay? He says he doesn't. He says he's got things covered. He's weirdly good about some things. Like, he can manage his money, as far as I can tell. Like, but he talks to things that aren't sentient. Round Ball Defender says, I live in SWFL, I think Southwest Florida. Most sunsets are cloudless. I don't know why why would the polarity of it have anything to do with clouds? Insane. Pat in the chat says, okay, Ms. Calculus, what's the first derivative of x squared? Don't tell her it's 2x. And a really good person would say, with respect to x, you mean? Yes, it's 2x. The Imaginator Creator says, wow, a model, I guess. But how does a lunar eclipse work on this model? Well, the same way as it works on all the other flat Earth models. It doesn't. Timbo Turtle says, shadows are pointing south for me now in Canberra. Fact-based, of course they are. Fact-based says shadows south in Queensland, Australia right now. How? That is a crazy thing to claim. Caucasian Sensation, I'll be honest here. I think we're dealing with a disability here. She can't possibly be this out of touch with reality unless she's struggling. To tell you, the email exchanges I had with her were very normal. I had no idea that. I mean, she went deep end instantly. So, Mark Beiser says, how does choosing what you believe even work? Now, with a religion, yes. Things that are supernatural, yes. But things that are physical, you should not have a religion about things that are physical, things that you can go measure, things you can test. You can test whether or not shadows point south. You can just ask someone who lives in the right part of the world. But no, her belief says that it's not possible, therefore it's not possible. That's not rational. Charlie Welch says, like Mikey Smith, they need to leave him alone. Mikey Smith. Like, what do you do? Yes, in one instance, yes. The guy's crazy, clearly. On the other hand, he's constantly out on YouTube doing things. He's going after people, saying things, putting himself in the front, trying to, right? He's sending letters to the Canadian Space Agency saying that he's going to sue them. It's a weird balance, right? You don't want to take away somebody's ability to get on the internet, but at the same time, it's not benefiting Mikey. It's not benefiting Marisa, right? It just feeds more insanity into them, and then they can go out onto the internet and share more of that insanity. I have no idea what might solve that problem, but the internet has allowed stupid people to find other stupid people. That's what the flat earthers are. It's stupid people that found themselves, versions of themselves in another city that they otherwise could not have found because they would have been isolated, right? They talk to one person. They talk to the 10 people that they might run into in a day or a week or a month. And they'd be like, yeah, that's a good boy. You're crazy. Go back to your home or wherever. And they'd sit at home. They didn't have anything. They couldn't easily and quickly communicate with other people. But the internet has enabled that to happen. It's lowered the bar to fast communication with idiots. Okay. Chronic Avenger says, why is the Singleton sundial in Australia pointed south? Pat in the chat says, well, that was something. Thank you for that. Jeff C says, mass attracts mass. Miley Cyrus was attracted to wrecking balls. She came in like a wrecking ball. It's a simile. It's not serious. It's not similes and metaphors and hyperbole, metaphorical speaking, paraphrase. That's what the fundamental, that's what the flirts do with the Bible, isn't it? Judy Bassett had a €8 super chat. Thank you for that, Judy. Tulio for $2 says, why are rainbows the new enemies of the Flurfers? That's his first super chat. Thank you for that, Tulio. Well, because they've built this, they've heard from their Papa Flurfs that rainbows are only possible in some way. That makes no sense, of course, but therefore rainbows can't happen inside because a Papa Flurf has said it, then they repeat it, and of course it's become part of their religion. So when you show that it's possible, they must deny it. They are not seeking truth. Dave Fierce says it's bad to be the second name of something. Nobody calls their motorcycle Davison, and now poor Morley is Mitchell's son. I already read that already. Stephen York says, why is this, oh, come on. Because why is she so angry? But it was a little mean. Stephen York. Be nicer. Be nicer. But yeah, she was a bit angry. Icy Spin says, ever watch King Crocoduck? Highly recommend it. I've watched a little. I gotta tell you, I watch things with my wife. I watch stuff with my family sometimes. We'll go to movies or whatever. But when it comes to watching YouTube, I mostly read things for research or watch things for research, or watch Flat Earth stuff for research. But there's a few that I definitely try to watch. King Crocoduck is not one of them. Mark Rober is one of them. Fortunately, it only does one a month, so I'll watch that with my kids. Janosch says, Hans Gruber, bring in the Flugenlayer. I can't pronounce that. Flugen, and I'm sure I'm pronouncing that wrong because it's got an umlaut over it. Flugen Gem Schuyler. Can't be right. Oh, he's debated Kent Hovind. What's the safe word? That's not the safe word from... Yes. Oh. Is that from Eurotrip? The safe word in Eurotrip is not pronounced. I have no idea how you pronounce it. There's letters that aren't letters in it. Small Time Art says we need her to debate tracation. I don't care what I have to do or how many farm animals I have to sacrifice to whatever god to make this happen. Oh, her and tracation would be crazy. Russell Flag says, why did the chicken cross the Mobius strip? To get to the same side. Icy Spin says, I wonder what percentage of guests stay tuned in after leaving. Some do. Now, I always act as if they do, right? I try not to dramatically change whatever, right? There's things I won't say when they're here. There's things I would say when they're gone. But in general, I'm not just like going off on them. I'm in my head. I'm assuming that they're watching. I'm still trying to be appropriate enough, sort of, kind of. I don't know. You tell me if you think I'm doing a good job or a bad job of it, I guess. The rabbit says she is inventing the world, so the shadows have to follow her rules. We will get that rap song one day also. And Tommy Gronvald, you heard it here first. MC Dune does his research on YouTube. When I'm researching flat earthers, absolutely. But what I do actually spend a good deal of time is watching physics lectures from professors. Walter Lewin, of course, I've listened to multiple times. Because I don't remember all of this. So if there's a topic, I want to listen to a lecture on it. He's got some. There's a lady, I forget her name. She's really good. I like her. She does a better job than Walter Lewin, I think. Teaches at a pretty good university. So, Stringers one says, I watch cat videos. Let's see. Matt Klein says, I've gotten Red's rhetoric to agree to debate Witsit. I've gotten Witsit to agree to debate Reds. Where can we get them to debate at? Whose channel? Modern Day Debate would be probably the one that would work. Witsit will go there. Reds, I don't know. Your other choice maybe would be Non Sequitur. I don't know if Witsit would go there. Witsit would go to Jaren, but I don't think that's an appropriate place. Reds and Jaren, they have some history. So, I'd prefer to see it on Non Sequitur probably than Modern Day Debate, though I don't know. I don't watch Non Sequitur anymore. Since there's a whole bunch of crap, I don't watch it after that. So Steve, I don't have a problem with it, but I just don't care all that much. So Mark Beiser, I'm indoctrinating myself. And that's the thing that they never get. This isn't indoctrination. This is based on empirical evidence. And if you doubt it, you can go test it. That's the point. So, all right. So, Eric Burns says, I might do some online classes following textbooks. There you go. Okay, well, I have another stream coming up, and it's been quite a bit delayed. I think what I will do is I'm going to push it back to start at my time, 11:30. It's 11:16 right now. It's, yeah, of course, it says it's overdue. So there we go. Save it right there. So there it is. If you see the title, Pathological Narcissistic Grandiosity. So, it's just me. It's just me in that one. I have a bunch of stuff. So, Repo Sandman says, I like the great debate community, but Steve kind of broke it. Yeah. It's unfortunate that there isn't another debate host channel that's kind of bigger. Modern Day Debate is the biggest I know of. And I don't know. If you look at the flurfs in there, it is a cesspool. The flurfs in there it's James, I don't know. James has a massive number of flurfs that watch all of his videos. It's crazy. So, anyway, so if you're watching, to make sure you jump to this next one. If you're interested, somebody maybe put the link in. I'm not going to do a long intro to that, to the roll in with the guitar music and all that. I'm not going to do that. Just warning you. So anyway, people, thank you very much. Oh yeah. Stringers one, all flirts because James bans us. That's a problem. And I talked to James. James and I would talk. And he has a little bit of animosity towards some of the Globers. Some earned. Some of you have gone over the limit, I think. But I think he just has a chip on his shoulder too. So anyway, all right, people. Thank you very much. Thank you a ton. Is a massive amount of super chats. This is, I can't thank you enough. So this next one, the first section, I will just be doing a presentation. So I won't intentionally, I'm not going to be watching the chat. So you know, people, thank you very much. We'll see you in the next one.